Hi everyone, welcome to the Bradford Cloud User Group's August Meetup. I'll give you a quick rundown of what's going to happen tonight before I hand over to our first speaker. So we'll have a first session with John Lunn. We'll be talking about AIoT and exploring video analytics at the edge. And if you've got any questions in between, stick them in the chat. We'll have a QA session at the end of John's session. Then we'll have a second session with Pete Gallagher talking about building a Raspberry Pi robot arm with .NET 5, Blazor and Signal R. Again, if you've got any questions during the session, please stick them in chat. Or if you want to ask the question at the end, you can ask the questions at the end yourself. Just come off mute. We'll have a QA session before we wrap up. Before I hand over to John, for those of you that don't know John's a solutions architect working for BT. He's a community blogger, newly minted MVP. Congratulations, John. Well done. And a community speaker. So I'll hand over to John if that's okay. If you're good to go, John.
Yeah, thanks, guys. No, pleasure to be here. So, yeah, thanks for the accolade. Been a quite a whirlwind of a last month, to be honest. So, right, I'm going to share my screen. Make sure I share the right one this time. Let me know when you can see.
Yeah. Oh. Yeah, got it.
All coming through. Okie dokie. Right, we're going to kick off then. This is going to be a feat of engineering and IT internet bandwidth sharing, I think, because, yeah, just before we kicked off, I was explaining to the guys that I've been having a few little niggles that kind of takes my PC offline. So I've got a backup plan if that does happen. So bear with if I go silent, radio silent. Okay. To kick things off then, as I get my little PowerPoint slide up and ready. So yeah, hi everybody, my name's John Lunn. You know, as Sarge said then, I work for BT Enterprise in the UK as a technical architect. I'm a traditional IT ops guy, so I was joking with the guys before how I ended up talking about artificial intelligence and IoT at the edge. Yeah, God only knows. But anyway, so you can catch me on Twitter. I'm quite active in the community. I've got a blog, johnnychips.com. I'm going to kick off with a few kind of shameless self-promotion. I'm one of the co-organisers of the Welsh Azure user group, so if you've seen that around, you know, please join us and say hello. Got my YouTube channel. I do a couple of weekly shows and in conversation with videos where we have a chat with various people across the community, and yeah, it's really good fun. So had that running on YouTube for about 6 months now, so I'm doing all sorts of bits and pieces and just having a bit of fun, I think is probably the best way to kind of frame it. And I've got my blog at johnnychips.com. So yeah, shameless self-promotion out the way. Let's get on with the matter at hand. So right, to be honest with you, caveat up front, what we're looking at now, 6:05. I'm assuming I've got about 45 minutes. This is a huge agenda, if I'm being quite frank with you. I'm not going to read it out verbatim, but we're going to kick off with a little bit of scene setting, how I got involved with this and why I got involved with this and kind of where this journey has taken me before we kind of kick into really what we're going to look at is this end-to-end solution of, we're going to explore hardware accelerated video analytics on an IoT edge device. Now, there's a lot of words there, so hopefully as we go through this session, like Sarge says there, stick any questions you've got in the chat, and you know, I think feel free to come off mute and obviously chip in if you need to. There is a lot to get to, so I'm going to give you kind of a brief overview. I'm going to probably keep things at relatively high level and dig into the detail as we go through various areas. We're going to have a look at the solution overview, what IoT Hub is, IoT Edge, and you know how these IoT devices communicate with each other. We're going to look at specifically the Nvidia Jetson Nano device and you know kind of why I bought one and why I started to use that to kind of do some of this cool stuff. We're going to touch on what the Nvidia DeepStream SDK is in terms of you know what the solution is that I'm using to do some of this video analytics. Before we kind of dig into, like I say, there's a few other areas. Looking at AI models, how do we train our own custom vision AI model? How do we use a pre-trained model? Then we move on to filtering telemetry and then modeling with time series insights and looking at visualizing some of this data. Basically, there's a lot of points on the agenda, but it's all about looking at how do we join up that end-to-end solution? How do we do something that is actually a meaningful start and finish, if that makes sense? Okay, so moving on then, scene setting. What is going on? So why did I get involved? So a couple of months ago, my good friend Pete Gallagher is going to do the session afterwards. You know, you can all blame him for getting me involved in this sort of stuff. There he is. Yeah, oops. Nice one, Pete. So I was joking again, how did I end up talking about AI and machine learning and AI object detection on edge devices? So there's a lot of ground to cover here now. So fundamentally, I'm going to try and rattle through it because I've already used 3 minutes up and I haven't even started yet. But the Nvidia Jetson Nano is a developer board. I just bought one because I saw a green box in the background of one of Pete's videos, and Paul DiCarlo, one of the cloud developer advocates. I've been playing with Raspberry Pi. I've been dabbling around using various bits and pieces, mainly for my own learning and understanding. And, you know, it's like anything when, there we go. Nice one, Pete. You got another one there, see? We all hold up these green boxes as we can. And, you know, fundamentally, it was around, I just wanted to get into this zone of, you know, having resistors and lamps and LEDs and sensors on my desk and play with things and wire them up together and try and do something. So caveat, I'm not a developer, although, you know, arguably I'm probably entering into that territory now. I've dabbled around the edges, but I'm a traditional IT ops kind of person, and you know, I love this kind of thing as a passion thing more than anything. So I bought one of these devices. We're going to dig into the specs of that in a little while. But me being me, you know, for those that have followed me, I've got a nice PC that I built, and so I take these pictures, you know, tweet out about Nvidia. There's a little camera that I bought off Amazon. It's a Wi-Fi camera. It's sat up by the side of me there, and we're going to be using that in a second. And that's the actual Nvidia Jetson Nano in a little case with a fan on it, sat down here on my desk. So I started tweeting out about these things, and I got in contact with a guy from Microsoft called Paul DiCarlo, and he saw that I kind of run through a lot of, he prepared this GitHub repository, and I kind of picked up all of these things that he was doing and ran with it. And I think over a period of 2 or 3 days, I kind of got this end-to-end solution up and running and working to a point. And it was really good fun, really good fun. I learned a lot, and it was a great experience doing it. And that's what I'm going to talk to you about today. So when I was tweeting about these things, Paul DiCarlo actually messaged me. This was a slide that he sent me. He actually spoke at the Nvidia GTC this year, and he actually called out that, you know, I guess you could call it my enthusiasm for wanting to learn and do some of these things. This was a slide that he presented at Nvidia GTC, and it's basically around, you know, inspiring others to kind of take the same journey. Because look, this is an end-to-end solution. Has it got gaps? Are there, you know, it's not necessarily production ready, but it's all about the learnings, and that was the exciting thing for me. So that's scene setting. Hopefully that makes sense to everybody. That's 5 minutes over with, and I'm going to keep a beady eye on the clock. So solution overview, what are we going to look at today then? So without further ado, we're going to look at the fact that we've got all of this stuff that we can kind of use and make use of in order to develop an end-to-end solution, specifically around using an IoT edge device, and we'll get into that in a second, but specifically to do some video analytics, so to analyze video and detect objects within that video. That's the solution we're talking about today. So we're going to be covering what Azure IoT Edge is and the fact that it uses an SDK. I'm not going to dwell on that too much, but hopefully give you a little bit of flavor that I'm probably going to cover up a lot of the dev side of things to a certain extent. We're going to move into what the IoT Hub. So the IoT Hub is kind of central. It lives in Azure. It's a component that you can spin up, a managed service within Azure that you can use to receive messages. We're going to touch on that. We're also going to use Stream Analytics. Now, for me, I'd heard about Stream Analytics. I've never really done a great deal with it, but I thought, right, this will give me an opportunity to actually not just understand it at a high level, but put it into practice and understand what the context is that you might want to use Stream Analytics. There's 2 cool things to think about there as well, and we'll get to those, so we'll touch on those later. We're going to take time series insights as a method of trying to visualize some of this data. So this video analytics is going to be streaming lots of messages out to the IoT Hub. We're going to use a feature, another feature set that we can spin up in Azure called time series insights, in order to try and visualize, capture some of that data. And I know, Imran, you mentioned you bought that MX chip. I'm actually going to use an MX chip to kind of do that, because, you know, people love me for saying, you know, it gives temperature and humidity. Yeah, there we go. I got one down here. The USB is not long enough to. I got a picture of it in a second, but I might be being boring, Pete. I might be boring. Anyway, we're going to get to that now. And finally, well, not finally, we're going to use Power BI, and we're going to touch on a little bit of storage. But come on, let's move on, because we're getting there. So what is IoT Edge? In short, I'm going to paraphrase. I'm going to speak in layman's terms, because there is quite a lot to get through. IoT Edge is a little computer. Yeah, it's a PC. It's a device that has a CPU or a bunch of CPU, memory, RAM, disk space, whether that be an SD card or a huge disk array. You know, it can be of any size. I'm using the Jetson Nano, which is a small form factor PC, but fundamentally what it's got is this runtime, this set of they're called modules, but they're fundamentally containers. They're containers that run on this device, and it's almost like a mini container orchestration engine that this IoT Edge has as part of this system module. So it runs them, and we can also install custom modules that have some business logic to it. So things like, as this diagram says, telemetry, insights, action. They're just about business logic compacted into a container that we can run and spin up in, on our little device or big device, whatever you've got. I've got a little device at the moment, but we'll stop talking about little and big. Point being is that we've got some sensor data, and I realize I'm circling the screen. You can't see what I'm circling, so I'm going to do this. So on this diagram, it's showing robot arms, which is Pete's bag for the next, I'm just laughing at the smiley faces, for the next session. But in our case, this is fundamentally going to be cameras. It's going to do something. It's going to send data to the IoT Edge device that's then in turn going to send something up to that IoT Hub, that thing that's central to where we are at the moment. Quick note about messaging in terms of how do these devices communicate with each other. Again, I'm going to rattle through this at speed, not to dwell on it too much, just to give you a bit of a flavor, but fundamentally there are a couple of protocols that are used for these modules and for the devices to send messaging to and from the IoT Hub that's in Azure. Primarily, if you're using something like an IoT Edge device or a gateway, a device that's going to take feeds from many devices sat around, so sensor information dotted around a manufacturing shop floor, it would feed into a gateway device. Typically, you'd probably be using something called AMQP as the protocol for messaging. Equally, if you've got like a very small sensor, a small device that's like a microcontroller, something, I've not got one, I have got one to hand, but something like that, that's really just running a couple of sensors, information and doing a few basic things, you might be using something like MQTT or even just straight out HTTPS. The point to note is that these protocols by default do have certain port requirements. So therefore, if you are running behind firewalls, you obviously need to open that up to get communication flowing over to the internet. Good news is all protocols run over WebSockets. So if all else fails, we can just use 443, which typically businesses have open per se because we all like to access the internet. But I'm not going to dwell on it other than that. That's certainly an area that if you want to know more, dig into it. But you can see fundamentally, we've got camera information going through our edge device, a gateway in this diagram. It's sending it up to a public endpoint that sits in IoT Hub. And then we're going to use Power BI and time series insights to actually hopefully make a little bit of sense with this data. Okay, I've only got a few more slides. I'm going to nip back and forth into these, but we'll quickly look at what the Jetson Nano is first. So Jetson Nano, like I said, it's more or less, layman's terms, it's a bit like a Raspberry Pi on steroids. It's got a huge GPU. If you do buy one, then buy one, absolutely. Price point for a 2 gig unit is around about the £60 mark. You've got this wonking great heatsink sat on there. So if you do buy one and you go and do some of this, do go and buy a fan because they do get very hot very quickly. I learned that lesson the way that you expect I learned that lesson. So they are, to all intents and purposes, I believe they've even got the same GPIO sort of outputs, pin arrangement as the Raspberry Pi. So if you have dabbled or you want to dabble in Raspberry Pi, there are some crossover between that. But fundamentally, I'm not using any of the GPIO for this particular session. I'm going to be using some RTSP camera feeds. So we'll get onto that. Like I say, Jetson Nano, I got a 2 gig version, £60 price point. You can get 4 gig, which pushes it around £90 to £100, and you can go onwards and upwards. There's a series of different developer kits that you can buy from Nvidia. The main point of why I bought the Nvidia Jetson Nano is because it's got this processing power. It's got like 128 core GPU chip sat on there that we can use for a lot of parallel processing, which is, certainly what's needed when it comes into kind of doing some inferencing on real-time video, which we're about to get to. So, okay, first thing, NVIDIA DeepStream SDK. Like I say, I'm not a developer, but fundamentally, NVIDIA have released this SDK, which basically gives developers the ability to develop some form of an AI object detection model that can be used in various different industries. Typically, we're going to be looking at the cameras, but from a safety or security perspective, object detection for various different things, but retail, construction, manufacturing. Fundamentally, this is sensor data that's been sent into our edge device that's represented by that. sending information up to the cloud, which is going to be our IoT hub. And then we're going to do something with that data in the cloud. We're going to do things like analyze the data and put some visualization around it. But fundamentally, it's a specific developer kit. And I'm not going to dwell on this too much because time permitting, but fundamentally it allows us to write, if we want, applications, and I'm going to get to the spoiler in a second. We can write in C, C++, we can actually, write Python applications if we want, and we can use this stack that fundamentally this is being developed to make use of the hardware on the Jetson Nano, to make most efficient use of the GPU power that we've got with those 128 cores. You can see we've got this layer of CUDA-X, which is really around how we use AI object detection models using CUDA or TensorRT. Part of this SDK is this thing called a Triton inference server, which kind of takes different versions of models and allows them to run on via using the DeepStream SDK on things like the Jetson Nano, plus other devices and containers. But fundamentally, I'm not going to dwell on that too much because when Nvidia wrote this, they wrote it with people like me in mind, in that I'm not going to develop my own application. So they did a good thing and put a whole bunch of sample applications on there that we can dip into. Again, this is the sample application. This is called a pipeline, okay? And again, I'm not going to dwell on it too much, but we've got a couple of camera feeds. We're going to be passing those camera feeds through this pipeline where we're going to decode. We're going to multiplex these cameras together to do some inferencing over it. We're going to get there. We're then going to feed that into an object detection model, which is going to be, you can have it as a primary detector to detect whatever it is that you want. We'll get to that part, but things like people, cars, humans, pets, plants, whatever it may be. This goes through this pipeline, and you could, if you wanted to, throw it through a secondary classifier, which basically means if I've detected a car at my first inference stage, by the time it gets to the secondary classifier, we could run another inference over it using another more granular model to say, okay, I've noticed it's a car, but what make, what model, what color is that car, that kind of stuff. And fundamentally, it's a whole pipeline of SDK libraries that we can use to do this app. So that's all been strung together for us. We've got a sample app that we're going to use for this. If you want to learn more, and I suggest you do, if you are interested in this, go and jump onto these URLs. There's a free course there with getting started with the Jetson Nano, with AI specifically. That's great. I went through that. And I must add, I also went through the course that Paul DiCarlo ran that is available still for free, I believe, on the Deep Learning Institute Nvidia site, that kind of talks through a lot of this deep stream stuff that I'm about to show you, probably at a higher level just for time. And also, there's the link to the Deep Stream Developer Guide if you did want to keep yourself awake at night and read through that. So it's great, superb information, but a lot to cram into a 45-minute session. So at that point, I'm going to quickly flick over to my my desktop, if this works for me. Right, so first off, there's our Nvidia Jetson Nano. I've got a little screen for it. There's nothing running on it at the moment. It's just a flavor of Linux that's there. It's running. It's up and ready for us to access and do some stuff with. I have pre-loaded it. So if I go over to my desktop and flick over to my Azure portal first and foremost, and I'm on my time series insights. So what I'm going to do, I'm going to jump over to my IoT Hub. Like I say, I'm not going to go into too much detail about how you set these things up in Azure. There, if you're familiar with Azure, a lot of the time it's point and click, or if you want to do code, you can do all that great stuff. I'm not going to dwell on that today, like I say, purely for time purposes. But if we flick over, I've got this thing called Johnny Chip's Jetson IoT Hub. It's set up. It's been running for a little while. You can see today I've got things like it's had 487 messages. Great. So I'm getting something. That's great because I've already configured my IoT Edge device. And by the way, if you spotted the link earlier on with the Paul DiCarlo slide, please do make note of this GitHub repo. So toolblock/intelligent video analytics. Just Google GitHub toolblock and find this Paul DiCarlo session, because you can absolutely follow along with everything that I'm about to show you. So back to our IoT Hub, we've already pre-configured an Edge device, which is a specific device. And if I click on that device, we can see we can get some specific information about the device. And namely, do you remember I said that the device contains modules, i.e. containers? So by default, we get these two system modules, the Edge Agent, the Edge Hub. They kind of get installed as part of you signing up and registering and associating that with your IoT Hub in Azure. And you've got this concept then that you can load custom modules onto the edge device. So I've got 4 custom modules. Like I say, I've already preloaded them for a time-saving exercise, but I will quickly touch on how you can load those modules on and where you can get them from, and actually what are they doing? What are these modules doing? So we got 4 custom modules. There's a couple of different ways you can get these modules on. You can actually do it through the portal here. We could go to set module. We could do a search for a specific module in the Azure Marketplace. So, for example, you'll see that I've got one called Nvidia DeepStream SDK. If I do a quick search for Nvid, they're not going to show up for some ridiculous reason. Don't ask me why. Okay, maybe it doesn't like capitals. So they are actually marketplace images. So this Nvidia DeepStream SDK is packaged up as a container ready for you to throw straight onto the onto a device of your choice. Now that's one way of doing it. We could do that, and equally some of these modules, things like DeepStream Analytics and blob storage on IoT Edge. I'll see what the time's like. I might dip into these to show you a little bit, but I might have to skip them because, like I said, there's a lot. Certainly this camera tagging module is quite a cool thing, and we might start there. But the other thing to note, we can drop that module onto our device. The other way we could do it is literally through VS Code. So we can actually do a deployment template, which is all JSON formatted template that we can use to deploy to our IoT Edge device. That is basically formatted in a sense that, you know, I'm not going to profess that you know what's on my screen here, but we got the concept of first, we've got our system modules with the Edge agent. We know we're pulling that Edge agent from a specific container registry. There's a Microsoft container registry. The same for the Edge Hub, same container registry. We're using IoT Edge -Hub version 1.2. And you can see we're doing some settings on those containers. Well, the system is, you know, these can be generated for you via VS Code. And then we can define our custom modules. So you'll see I've got this Nvidia DeepStream SDK that's coming from the Nvidia container registry with a particular version. And one thing to note, you'll see that I've got an entry point of this DeepStream Test App 5. That's our pre-canned sample app that we're going to use for this demo. And we can configure that. We don't need to be a developer, but we can use the guides that are provided by Nvidia to actually pass through a particular text file that will hold all of the settings that are going to generate the actual application when it runs. So in this case, you can see I'm referencing this dsconfig YOLO v3 tiny, which if I browse down is actually here. And I'm going to quickly, I'm not going to verbatim go through this, but think of this as your configuration file for what you want your particular application to look like. So I think what I'll do now is I'll quickly flick over to my Jetson Nano, and you can see I'll just use the IoT Edge is the system module that's running on my Jetson Nano. You can see I've got 2 running modules, which are the Edge agent and Hub. And by the way, if I disappear at any point now, because hopefully not, I'll jump onto my backup system over here, because for some reason it's been playing up the last day or so. I found out last night recording a video and cutting my Wi-Fi off. Hopefully we'll stay all good. So we can use standard Docker commands. So if I just up arrow a few times, I'm sure I've got, rather than me typing, so up arrow, I can restart my Nvidia DeepStream SDK module. So I think what I'll do is I will do that one first. So fundamentally what's happening in the background, and if I flick over to my Jetson Nano, at some point soon you will see something appear, but I'll keep flicking back and forth between that. And the other module that I'm going to start at whilst we're doing this is the DeepStream with a capital S, the DeepStream Analytics module. So the DeepStream Analytics module we will get to in a little while to understand what that actually is. But it's a Stream Analytics job actually running on the Edge device. So we will get to that. So they're now starting up. I'll flick back over to the correct screen. And there we go. So look, this is the Buddy's special prize. This is what you could have won. I'm kind of showing you the application, and I'm going to talk about actually what that's showing us now. So currently, I'm not going to flick over to it yet, but you can see I'm pointing at the camera. I don't know how delayed it is. There's a slight delay in it. So I'm pointing over here now, and eventually it'll pick that up for me. That's a studio camera. The top camera is a live feed that is actually pointed out the window of my where I'm at the minute, out into the street. And you can see that we got these bounding boxes. So it's actually doing some inferencing and detection on the actual cameras itself. And this is the sample 5 app that we're actually running. So if we quickly flick back over now to my desktop and let's take a look at actually what's going on here. Docker logs, Nvidia. I'm going to look inside that container now and actually see what's going on. So there's a lot going on there. You can see all this stuff. It's a bit like the Matrix flying up my screen there. So every few seconds, I'm getting a few messages sent up. Now, that's a lot going on. And this is all happening on that Jetson Nano. This is actually, every time there's one of those bounding boxes that appears, it's actually creating one of those messages that's flying up the screen there. And you can see it flying up the screen. So I'm going to stop it to stop flying up the screen so we can actually have a quick look at what one of those actually is saying. So hopefully, I mean, that's big enough that you can read, but you can start to see now, actually, it's a message that's being sent using one of those protocols that we spoke about earlier. We've got a few parameters or properties to this message. We've got timestamp, which you can probably guess what that is. Sensor ID, well, it's a studio. I've got another sensor ID, it's a street. Bearing in mind, I've named the one camera studio, the other one street. And we've got these, I mean, if I scroll up, you can see probably there's possibly somewhere it's detected 2 or 3 objects in one sitting. And in typical fashion, it probably won't be there now. So it's not always one. For some reason, it's only detecting one thing at a time at the moment, mainly because there's probably one car out in the street. I mean, let's have a look. Oh, it should be detecting a few, but as you can see, there's one white box and occasionally there's a red box around my monitor. And I'll dip into that now quickly so you can see what that looks like. But if I'm using a KVM now just to, so if I click on this camera here, part of the application, can actually zoom in and you can start to see that it's actually detecting me as a person and it's detecting that screen as a laptop. Well, that's close enough, and we'll get to exactly why that's not bang on in a second. And likewise, if I click on this car, there's a car that's live, that is right driving into the street at the minute. It's detecting the car. For some reason, it's looking at the LNB on my satellite dish and detecting that as a traffic light. Again, that's important to understand. Why is it not detecting it? Why is it not that accurate? And we'll talk about that in a second. So fundamentally, I'm going to flick back over to the desktop. I've got 2 cameras. Those 2 cameras are multiplexed together. They're sat one above each other. You know, why couldn't I have 3, 4, 5, 6 cameras? The answer is I could, but we're constrained to the size of our device. Remember, this is a 2 gig developer kit. What I found is 2 cameras is about right, but I'm starting to get a little bit of a performance issue. And like I say, if we go back to the logs, you know, just because I've come out of those logs doesn't mean to say they're still not going. They're going. They are absolutely going. They're flying. But where are they flying to? Okay, that's the question. Where are all these messages going? So I'm just going to pause that for a second and quickly drop into back to our deployment template. So again, we can either look at the deployment template and we can see we've got all of these containers on our that we've deployed to our device. And we're looking for something called routing, which I've probably gone past. There it is. So those messages are actually being sent from my Nvidia DeepStream SDK module, my container. So I got this route called Nvidia DeepStream SDK. I want to send them to a Stream Analytics. So those messages are actually being sent from that module. And the way this denotes here, so output star, as you can probably guess, star denotes all output, is being sent into this brokered endpoint of a DeepStream Analytics, which is the name of the other module that I started up, that you might saw I started up. And it's being sent to this thing called the DeepStream input. And we'll touch on that when we start talking about Stream Analytics in a second. And you can see there's some other routes. Again, we'll talk about that. But basically what's happening is messages are being sent whenever there's that inference is being sent, and it's being sent to somewhere else. And this is kind of routing information to guide where it's going and how it's getting there. So moving swiftly on, that was a quick flavor. I'll drop back to, what am I dropping back to? The PowerPoint briefly to kind of shift to the next section. And the next section is, right, how are we getting that object detection model? How can we train our own model? And in fact, how can we train our own custom model? And are there any other options? So firstly, we'll dip into this in a second. I'll give you a brief tour of how we can train our own model and put that model on the Jetson Nano. I'm not going to show you in detail because we don't have time, but I'll show you some of the concepts of how we train our own model. But equally, there is the concept that we can actually use a pre-trained model. And in fact, that's actually what I'm doing for this demonstration, because, which I'll talk about, it does take quite a lot of time and effort, and dedication to get a very well-trained model, and I'll talk a little bit about that. But within the pre-trained model, we've got a couple of different options. Things like we can either use Nvidia optimized pre-trained models, you know, they're kind of really production grade object detection models. You can see the names of them here. I'm not using one of these. I'm using one of these general purpose models. And I probably gave the game away when you saw the name of that text file earlier, but my text file was YOLO v3. And actually, that's the object detection model that I'm actually running on the Nvidia at the moment. And the main reason that I did that, I mean, look, the SDK doesn't support all of these models, you know, for various reasons. There's various different types of model. But fundamentally, I've got a bad network quality. Are you okay? Yeah, I'm assuming.
Yeah.
You can
All
see,
good.
yeah, that's all right. Just got a bad network quality.
So good.
So trivia, YOLO stands for you only live once. I thought everybody knew that. But anyway, so yeah, you only look once. Well done, Dean. Thanks for correcting me there. But so basically, that is what I'm using. We're going to touch upon how we can train our own model at the moment. But the YOLO is a pre-trained, you know, it's a pre-trained general purpose model that is pretty much good. It's decent. It's been trained for a specific number of objects. It's been trained in bulk by thousands, if not hundreds of thousands, potentially, of images. And so it's got a pretty good, you know, match in terms of percentage match when it comes to detecting things. You'll notice I'm actually using the tiny model. Prizes for guessing why. It's because I'm on a small compute device. And look, the big general purpose model is quite huge, and it detects, you know, several hundred different types of things. I just wanted to get up and running quickly, and I knew that the YOLO tiny model could detect people and cars and things. In fact, the YOLO v3 model detects, I think, 80 different objects. And one of the things I found quite comical is that one of those objects, out of every object in the world that it could detect, it actually can detect giraffes. So I was quite intrigued to see whether or not I would actually detect a giraffe. Hold that thought, because we'll come to that in a second. We'll see if we can detect a giraffe later. So anyway, back to my desktop. We're going to fly back to my desktop, and I'm going to hide my slide deck. And we're going to take a look at that first option. So when it comes to actually using Custom Vision, Custom Vision is a website. It's a service that we can use via Microsoft. We can sign into it with our Azure AD account. We can set up a project, and I've done just that. And I know I'm flying at a rate of knots here, like I say, to kind of keep within times. So I'm going to sign in to my Custom Vision AI, and you'll see I've already got a model detected, you know, with a bunch of images in here. Now that's because I've been playing with it over the time, and you can see these are pre-tagged images because I've done this demo a couple of times now, and I did actually train a few images to start with, but I've also got this area of untagged. So if we click on that, these are all images, and you can see I've uploaded quite a lot that cover my studio camera. There's me eating a packet of crisps. No, there we are. So there's a few images that I've uploaded, and we'll get to, you know, John, that must have taken you a long time to upload all those images or even capture those images. Look, that's one of the reasons why I didn't decide to carry on with the Custom Vision, because it takes a lot of effort. So these haven't been tagged in the slightest, but with Custom Vision AI, we can upload images, we can select an image, and we get this this interface effectively that we can kind of browse over certain objects within our image, and it will automatically put this bounding box, not because it knows that it's a car, but because it can see that it's something different within the image itself. So I can click on that because it's kind of selected that car quite neatly. And because I've already tagged cars in other images, I can say, yeah, that's a car. So great. And what about this one? Oh, yeah, that's a car as well. So now I've tagged 2 cars. Okay, great. Let me move on. This image hasn't been tagged. That's a car. That's a car. I think you get the idea, and we could go on, and you get it. Yeah, this is going to take quite a long time. And I think generally speaking, even for Custom Vision to detect and able to be trained, you need kind of any tag that you use. You know, arguably I could type in my own tags by drawing my own box over that and calling it a drain cover. I'm not going to, I did actually at one stage. You can see there, that's a drain. If I want to use this, I need a minimum of 15 images with, you know, with 15 tags. So we need to tag 15 of the same object for it to be useful. And you can probably gauge that that model would be, okay, it would probably detect things if that camera image and the atmospheric conditions around that camera didn't change. But my problem was, look, cars drive past in the night. You know, I get rain. I'm inside there behind a pane of glass. So I get rain on the window, you know. So the point is that when you're training models, don't just train them for one atmospheric condition only, because it's going to impact on your probability of detecting objects correctly. And that was partly the problem that I was facing. So I thought, right, okay, I just want to use a general purpose model, which is why I went over to that YOLO model, and that's what I was using, which is why, you know, you could see that it was detecting, you know, the screen off to the side of me as a laptop, and why it was detecting that LMB as a traffic light, because it kind of, you know, in fairness, it does look a little bit more like a traffic light if you look at it. So that's a very brief tour around, and one other point that I just wanted to point out here is that, you know, fundamentally I'm using a couple of different cameras. So if I just quickly connect to one camera, hopefully it will connect. So I'm just using VLC player here, and those cameras that you saw at the beginning, the picture of those cameras, they're actually just little Wi-Fi enabled cameras off Amazon. So you can see I've just connected to one of them. I'm just connecting to it over RTSP. That's a live stream. You'll see it's not got any bounding boxes, because this is the raw feed that's being pulled into my application that is then having that inference done on it, yeah, across that multiplex set of 2 camera images. So I've got these images, and I thought, well, how are we going to capture those? You know, how can I capture those? I'm not going to sit here forever and a day and capture those images. So there's a couple of different ways, and I'll show you 2 of them very quickly. Firstly, do you recall that we had on our Jetson Nano another module? So if I go up to, tell you what I'm going to do briefly to stop me disconnecting, if I can. We'll see. We'll play it rough. No, I'm not. I'm going to stop it because it'll only conk out on me, and I'll end up looking silly. In fact, what I'll do, let me just quickly flick over to my Jetson Nano, just for the sake of actually not causing problems with my thing. I'm going to go up here and I'm going to click that application close. And actually what that's going to do is it's going to stop my container from running. I'm doing that just because I really don't want to drop off. And I think that was the main reason, was because I was just overloading the Jetson Nano. So if I do a quick IoT Edge list, we should hopefully see my, there we go. So that's stopped now, my Nvidia Deep Stream. What I'm going to do is I'm going to restart. Remember, we had these other modules, and I quickly want to show you, just to kind of show you the kind of camera tagging. Ho-hum, if I can spell. So we can start this thing called a camera tagging module. So whilst we're waiting for that to quickly spin up, which doesn't take long at all, we could probably go back over to our manifest, and let's just see if we can spot anything in our camera tagging module. Yeah, we've got this thing here. We're exposing a few ports. So I wonder what would happen if I tried to access port 3000 on my Nvidia Jetson Nano, which did I set it up? No, of course I didn't. 192 port 3000, and hopefully that started up. This is now running. This is a camera tagging module. Now, by default, it's set up to run this thing called Big Buck Bunny, which, yeah, look into it. Google Big Buck Bunny, and you'll understand why this is an RTSP stream that's being shown on here. But we can change the camera. So, you know, let me just see which one's actually going to work. I'm gonna guess. I'm going to hope that this one will work. But fundamentally, we can change our camera, and we can open up our own RTSP stream camera, which may or may not work. Yeah, that's taking a bit long for my liking. But the fundamental thing is that we've got this module that's running on our Nvidia Jetson device. I'm going to try Street Actual. Sounds like I named them because, you know, that was the actual street. But anyway, if that does connect, great. If it doesn't, I'm not going to dwell on it. The point being is this camera tagging module can connect to an RTSP stream, and you can then click on this capture button, and you could say, there's a car in here, and I give this image a name, car 01, and I could add the tag. I could save the image, and if I browse over to images, I've got a car, and hopefully that image, there it is. I've got an image there. I could upload that from the camera tagging module either to blob storage, which I'm going to skip over for the purposes of time, or custom vision. The point being, that's taking quite a lot of time to get through. Yeah, you hope you'll understand that that's quite a manual effort. So number 2, how did I capture my images? If I browse down to my desktop, I got this folder called capture, and I basically got, you know, a few, well, 1,111 images that I captured basically just by using a script, ffmpeg. Again, if you Google that and use it, you can run an auto capture script. So if I just open that up, all I really did is open with Notepad and captured my RTSP stream, went to sleep for 15 seconds, captured it again, or captured the other camera. Captured the same camera. And I actually did change that and capture. I alternated, went to sleep 15 seconds. So I just left that run for a good few hours. And that's how I didn't sit there. And the point is you're trying to gain as much detail as you can with as many different images so that you can tag them. Hope that made a lot of sense. I rushed through that in record-breaking time. So what I'll do, I'll quickly flick back over to the PowerPoint, and we'll click through to the next couple of slides to see what we're going to talk about next. We are going to talk about filtering telemetry with Stream Analytics. Okay, like I said before, Stream Analytics is something that I'd personally heard of, and I kind of knew what it did at a high level, but it wasn't really until I started doing this work with the IoT Edge scenario that it kind of brought it to life. But fundamentally, you know, taking data from something, we saw there were many messages streaming up the screen earlier, taking that data and doing something with it, and then sending it to the IoT Hub. That's where Stream Analytics comes in into play with it. So, like I say, I'm going to click through these. We're going to take the data on the IoT Edge device, and it's being sent on the first job I look at to the IoT Hub module, the system module that's on the Edge device itself. Then it's being sent to a Stream Analytics job on the Edge device itself before it's then sent to IoT Hub so that we can consume it using Power BI. A quick call out for any Stream Analytics jobs that we run on our IoT Edge. When you've got you know, an application or sensor information, it's kind of streaming through quite quickly. One of the main points about why you might want to do that on the Edge device is, look, you don't really, maybe you don't want to be sending this stream of data up to across the internet over to IoT Hub, you know, hundreds, possibly thousands of messages a second. So within Stream Analytics, you have this idea of windowing functions, and there's probably about half a dozen or so of them. The one main one that we're going to look at, or we're going to look at in a second with the Stream Analytics job, is this thing called a tumbling window, which basically takes all the messages over a prolonged period of time. In this image's case, it's every 10 seconds. In our case, it's every 15 seconds. And then it's going to do some processing. Then it's going to take the next 15 seconds, do some processing. So that's the basic remit behind what is actually happening with Stream Analytics. So I'm going to quickly flick back over to my my container here, and I'm going to restart my DeepStream SDK and hope that I stay online for at least a small period of time before I get cut off. So we can see I've got the important things I'm looking at here. I'm living dangerously now because I've got the camera tagging module still running, but DeepStream Analytics and my Nvidia DeepStream SDK is running. You know, let's just see, it's probably not quite there yet. It will open up on our Nvidia Jetson Nano fairly soon. But basically, before we get into the Stream Analytics, just remember that the way that was being displayed on the Jetson Nano there was all to do with this custom config file. Remember, I showed it to you earlier. Just keep in mind that configuration is done. Hopefully now you'll understand if I click on the right one. If we look at things like tile display, yes, I want a tile display. I want 2 rows and I want 1 column. So you can see I've got 2 rows, 2 cameras, 1 column. And the idea is you can set the width and height. You can put a clock on there. You can set the sources. So the first source, hopefully you'll see, that is actually my street RTSP feed from my camera that we've got. I've got another source, source 1, enabled. It's an RTSP URI. That's my other camera. So you can start to see that this is just a configuration file that I'm pumping into that module that it's then using to kind of bring up that display that is hopefully there by now. There it is. Hopefully that makes a bit of sense. Now, to dig into all of these parameters, there are a lot. And remember that pipeline we saw, there's lots of configuration we can do with how many times we want to inference and the frame rate and things like that. So there's lots of configuration that we could do. We could even pass through a video file. So it doesn't have to be an RTSP stream. It could be a pre-recorded video, you know, that we've got something, maybe we're doing video in the field and we bring the video back. We want to do some analysis over it. We could pump that into it. So there's so hugely flexible. But I just wanted to call that out before we quickly looked at the Stream Analytics. So Within our VS Code, we've got the ability to look at IoT Hub. How am I doing for time? 48. I'm closing in, not far off. You can see straight away I've got my storage. I'm not going to cover that off now. Skip over that one, but I've got these modules running. I could even right-click and I could start monitoring this built-in endpoint. And so why am I doing that? So we know that the DeepStream SDK is actually outputting lots of messages. There we go. So, right, I'm outputting lots of those messages at the moment, but hang on a second. Why am I not seeing these on my Jetson Nano there in IoT Hub in Azure? Right, there was a message at 21. There was a message at 36. I'm going to bet the next message is going to be at what, 51? Do we say 51? And I'm going to keep talking till it gets to 51 and actually give me a message because it's going to happen. There we go. So hopefully you can see that I've got all of these messages pumping out of the module that's on my edge device, go into my DeepStream Analytics module that's on my edge device. That DeepStream Analytics is doing something and it's sending a message back to me every 15 seconds. It's consolidating and doing some transform on that data. So we can see that in action. We can see that happening there live on the screen. Every 15 seconds, my IoT Hub is getting a message. So what is actually happening? Let's quickly delve over to my Azure portal and drop on to Stream Analytics jobs. And do you remember I said we've got edge jobs and we've got cloud jobs? Edge jobs, believe it or not, they run on the edge device itself, which is what's going on in our case. And do you remember those messaging, those routings that I pointed out earlier? Let's look at that. So if you recall, the routing that we had set up in our, if I can ever find my window, in our, God, I can't talk and move around the screen at the same time. Does everybody have that problem? I think so. So in our configuration file, so our deployment manifest, we had this routing configuration, just to refresh your memory, that all the outputs are going to be brokered into this DeepStream Analytics module and this thing called a DeepStream input. And look, we could do it in a manifest. We could do it through IoT Hub and configure that in the portal, in a nice GUI portal if you want that. There's our DeepStream input. So what's going on here? Well, we're running this SQL-like query, funnily enough. And actually what it's doing is it's taking all the messages that are coming from the Nvidia DeepStream SDK module. It's creating a table called flattened detections. It's doing some select statements to kind of tidy up that data and separate out all the objects into a, using regex to do that. Look, if you're a SQL person, fill your boots. You can go to town on here. We're actually doing some proper transform on that data. And what we're doing then is actually, you would have thought we'll do some transform and spit it out the other side. Well, we could do, but what we're actually doing is we're spitting it out to two different locations. So we've got two outputs. We've got one called aggregated detections and one called summarized detections. Whoa, hang on, what does that mean? So actually, we're taking all of that information, we're doing some transform on it, and we're spitting it out to two, using that tumbling window every 15 seconds, an output's called aggregated detections, but then we're doing something slightly different where maybe using, a smoothing function. So if in this case, what that's for is if a detection is detected a couple of times or it flickers, detects, doesn't detect, it kind of creates a false positive. So this actual function in SQL is using that data and acting as a bit of a smoothing function to give us more accurate results. And we're sending those out to a completely different output. So this is that publisher subscriber model wherein in IoT Hub or wherever we want, we can subscribe to those message tunnels or those message pathways, topics is what they're called, and we can pull that data out somewhere else. So does that make sense to everyone? Hopefully, for me, that was a bit of an epiphany. I went, oh, right, okay, I kind of get where Stream Analytics goes now. It takes a stream of data, does something to the data, spits it out to outputs. And remember, we've got all of these things. We've got event grids. We've got all sorts of things we could use within Azure to do some processing. So after speaking at 100 miles an hour again, I'm going to take my window off there so you can actually see my presentation. And I'm going to skip over to the next part. So I'm going to skip the cloud, the cloud stream analytics job, but there's another cloud job running, which is basically taking every message from the IoT Hub that runs in the cloud and sending out to a data set for Power BI. So time series insights modeling. Have I got much time left? I think I've got about 3 or 4 minutes left if I push my luck slightly. I can get through it. So time series insights, what I wanted to quickly do is show you that MX chip, and I kind of called this out because I'm going to show you a couple of time series insights. We've got all this data coming in, and I kind of deliberately use this MX chip because it gives prettier data and it's more understandable than just has it detected a person or has it detected a car. This gives time and humidity, which kind of fluctuates, and you can see how hot I'm getting in the studio now. So back over to the desktop. We'll have a look at time series insights again, which is a component of Azure, as you would expect. I've got this time series insights called JC Temp, which is taking a feed from that MX chip that you saw that Imran, you've got one yourself. You can kind of do this stuff if you want to, and it's not ambient, it's actually machine temperature. So all I'm doing is taking my machine temperature and my machine, no, I'm not, I'm taking humidity and temperature. I'm going to add them, and look, straight away, we've got the ability to kind of model, data. We've done nothing other than open a time series insights page. We've taken data from somewhere and we're kind of modeling it, and we can kind of zoom in and out and look at the history and look at the hot standby and limit it to the last couple of hours. So you can see literally over the last hour you can see how hot I'm getting because I'm talking so much. It's really hot in here. Well, actually, you can tell me how hot it is. It's a humidity of 56 and we've got a temperature of roughly about 33 degrees. Yes, I'm surrounded by lights and monitors and cameras, so you can't really blame me. The point being is that we've got the ability to hook in at a glance, quickly glean some insights out of that data. If I took you over to the time series insights of the camera sensor data, you can see that, oh, it's not as exciting. It doesn't curve very much because it's in fairness, it's not doing a huge amount other than detecting how many people are in the street over the last hour. So I can, as I've been talking, has this graph got any better? Well, it's gone up and down. So hopefully that's a quick demo of how time series insights, we can quickly hook up that data from Iot Hub to one of those topics, feed it into a time series insights session, and we can quickly glean those insights. That was time series insights. And to wrap up, I'm going to quickly give you a couple of minutes on the final section, which is not there, it's there. See, there's too many buttons. So the final action is we've looked at modeling data or looking at insights from data that we've detected over time series insights. Another thing that we can use is obviously Power BI. So from Power BI, people will probably be familiar with Power BI. How does that fit into this particular solution? So what have we looked at? We've looked at cameras associated to this Nvidia Jetson Nano SDK test application that's multiplexing those images together. It's doing inference across an image that's multiplexed of two cameras and telling me if there's a car or a person or a traffic light, an LMB that looks like a traffic light, or maybe even a giraffe. Maybe we could use some of those, the data insights to kind of dig in and tell us what we can see. And that's fundamentally what we've got here with Power BI. We've taken that cloud stream analytics job to take a feed from my IoT hub, pump it into a data set that's stored in Power BI. So that data is getting fed into my Power BI data set. I can now create a report on top of that data set, which is what I've done. And I've kind of just tweaked the timestamps because this is over the last couple of hours. Ignore the time at the moment because, yeah, I'm not even going. I couldn't change it from UTC time. So if anybody does know how to do that in Power BI, please let me know because it's not as simple as you might think. But anyway, you can see now over the last couple of hours, it's actually given us some detections. And actually, it's detected far more than cars or people because I'm using that YOLO model. So, moment of truth. Did we detect any giraffes? No, there's no giraffes in sunny South Wales, but there is pizza. So the job's a good one. Apparently, there's pizza. I might have a word with my son. He might have been eating a pizza in here. But there's a skateboard. Apparently, that might have been outside, actually, whatever. But the point is, with Power BI, we can start to actually now drill into this in kind of in an agile way, in a little bit more of a dynamic way, and look at the cameras, the sensors individually, and we can kind of make sense of that, and we can look at the time.
We lost you, John. If you can still hear us.
I think he did say if he disconnects, he'll come back on again.
I bet he
He's
did
back.
that on purpose.
Is he back?
That was just him.
Our Power BI dashboard, we've got
He's back.
the detections that it's taken. You know, we can start.
Sorry, John, we lost you for a bit. Oh, he's gone again.
Hopefully, we'll reconnect in a minute.
Thing that we need to look at. Oh, hello.
Is he back?
No, nobody wanted a question then.
John, are you back? We lost
It must
you
be. It must be all that scanning he's doing. He's grinded his network to a halt.
I've got to fire over to my.
Oh, he's back. He's
my
back.
backup schedule.
Yeah.
I've got to fire over to this one.
Yeah, he's back.
Which one am I back on? Am I back on? Am I back here?
You are here, John, yes.
You've got too many cameras, John.
Right, which one am I back on?
Yeah.
The original one you were looking at, John. Also, you've got
okay,
echo
so
now.
you can see me on that.
We can see you on the
Power BI on the screen.
Yeah.
Oh, I was so close to making it all the way through without actually dropping. Because what I'm going to do now is I'm going to click onto my last slide, and that is going to be, thank you. So can you see that? Tell me you can see it. Yeah, you can see it.
We can see it, yeah.
Guys, I'm slightly over. Apologies for being slightly over. There's 101 things that to talk about, but hopefully that was informative. If not,
it was. You could tell you need at least a few hours on that, don't you? Because you did go through that, and you did a really good job on that, John.
Excellent, John. Seriously.
I gave Pete some extra time there to set up his toys, so think nothing about it, Pete.
I know we're scheduled to finish about 8 o'clock, Pete, but you can go until 9 if you want. I'm sure they won't mind. If you have any questions, you can come off mute and ask the questions or put them into the chat. John, are you still with us?
I'm still there. I didn't breathe.
John's
So
still with us.
screen.
I've got John. I've got a question for anyone who wants to get started with IoT or any of this cool stuff you were doing. I've purchased, as you mentioned, one of these MX chipsets here. You know these. I'm not sure if you can see it, but I've just popped a link in the chat. Is this a good place to start?
Yeah, to be honest, my place to start was to follow Pete Gallagher, to be honest with you, and follow his shows on IoT Live. But do you know what? Yeah, it's like Pete says, you know, Pete is the man in terms of what, you know, he knows what's good and what's not sort of thing. But for me, I bought an MX chip and it was great to kind of just be able to plug and play to a certain extent. There's a lot of good sort of pre-built things and learning modules you can do through VS Code to upload onto that MX chip that kind of helps you. But, you know, if you have got a bit of cash, yeah, follow Pete because you'll need quite a bit of cash, to be honest. But if you can spare, you know, sort of 50, 60 pound, get yourself a reasonable Raspberry Pi. That's always a good place to go. You know, certainly MX chip is great, but as Pete will attest to, it's kind of temperature and humidity, and there's an accelerometer and some pressure in there as well. But you are kind of limited. Personally, I started on the Raspberry Pi. I found that it's a lot, you know, there's a lot of good things and lots of great resources. And like I say, genuinely follow Pete because he's always tweeting out about lots of good things. And, you know, obviously inspiration and little ideas. And there's a ton of resources on the web as well for kind of perking your interest. So, yeah, but the MX chip is not a bad place to have a crack at. But yeah, get a Pi as well. Or a Jetson Nano.
Oh, well done, mate. Are you blaming Pete for spending all that money on your
Absolutely?
On your gadgets?
He knows it.
Yeah,
he knows. I regularly blame Pete, and there's lots of people that do. So he's got a lot to answer for.
It's working. It's crowdfunding. It's just very weird. Crowdfunding experience. That's what we're doing.
I agree. No, I agree. I don't think anyone's got any further questions.
John, a question for me though. You know, the Visual Studio Code, what language was that? Was that just that wasn't PowerShell, was it? Was that just JSON?
On the right, there were a couple of different screens that I showed there, but I think the config file was just a text config file. That bit that you saw about putting in your sources and things like that. The stream analytics is SQL. When we looked at the deployment template, that was actually a JSON file. So it was JSON template, you know, a bit like an ARM template to a certain extent, written in JSON. So I don't think I covered any other languages there, but it was JSON, there was a simple text file, and there was some SQL that you saw there throughout that.
A question for you or Pete, really. You know, like when you look at these tutorials about Raspberry Pi, they talk about, you know, different languages like Python or, you know, C#, .NET, you know, there's various modules that you can do. So for a newcomer that's new to programming or new to any of this, where would you suggest they start?
Well, you know, I can tell you where I started, but I took, again, you know, Pete gets all the goodness. He can give you his view, and he's probably better off and far more educated and credible to give this information. But to be honest, I don't think it really matters where you start, is my answer. If you've done something with a programming language, just learn the programming concepts, learn, you know, learn what a function is, what a method, what a class, what libraries are. And then, you know, you kind of turn your hand to what it is. But look, you know, .NET is quite prevalent at the moment, and certainly you know, I'll let Pete speak for himself, but certainly from a Microsoft viewpoint and what's going on, .NET is great. I mean, Python, I've started to, you know, relearn Python and things like that. So it doesn't really matter as far as I'm concerned, or from my perspective. Pete may say, what's your thoughts, Pete, in where to start?
This is a wider conversation, really. It depends on where you are on that skill tree. I mean, if you're a mega C enthusiast, then just do C. It's definitely pick the correct tool for the job. But if you're brand spanking new, doing a programming language that involves text isn't necessarily the right place to start. You might be better off starting with microbit and doing it in a Scratch block-based language. Because you can teach yourself the concepts there without having to get down to the syntax of the programming language itself, or compilers even, and runtimes and things like that. I love the microbit. I've got a whole talk on getting started with IoT and not needing the actual equipment. You don't need to buy the kit because the simulators out there for all of this. So yeah, doing microbit's fantastic. If you want to do Arduino and you don't want to have to do C, because let's face it, who does want to do C? Because it's hard, then you can even do Arduino programming in a simulator using a block-based language. And then you can convert that into C, download it, and put it onto your Arduino, and it'll run. That's awesome to be able to do that. So, yeah, if you've got no experience, do that. Otherwise, pick the language, because if you do a Raspberry Pi, you pretty much choose your language. Do C, C#, Python, Scratch if you want, anything.
Oh, thank you.
Sarge, or you could just, actually, you're already following him, just follow at P_codes.
Yeah.
All the answers.
Yeah, and then also that second mortgage.
Yeah, poor John.
Thank you, John. Excellent session. Imran?
Thanks for having me.
Yeah. Yeah, it was a great session, John. Really appreciate you coming on, mate. Thank you very much, mate.
Thank you,
Great
mate.
session. It looks like Pete's doing really well with you, mate.
Yeah, well, it's over to the teacher now, yeah?
Over to the teacher, yeah, absolutely. A second session for tonight. I've got two options here. I either introduce Pete and then only give him 5 minutes for the talk, or just hand over to Pete, because he's actually involved with a ton of stuff at the moment, and I was just reading up about him. Not that I'm stalking him, but I've been following Pete on Twitter for about 1.5 years.
You wouldn't be the first one. Don't worry about it. He's got everything going. So yeah, Pete Gallagher, he's an IoT guru, as everyone knows. I first heard of this little device here, you know, via Pete's tweet. So I've actually purchased one. Not actually taken out a second mortgage yet. I'm not there yet. But yeah, he's a 2-time Microsoft MVP. You know what? I could go on and on. He's involved with several meetup groups. I've actually typed it all out. But I'll hand it over to yourself, Pete. Otherwise, I'll be here all night. Let you crack on with, as it says there, building a Raspberry Pi robot arm with .NET 5, Blazor, and SignalR. Yes, over to you, mate. Yeah, even the title of the talk's long, and that hasn't got everything in it either. So, yes, it's good. I love this. Yes, I mean, if you're not here to watch this talk, then stay anyway, because it'll be interesting. But yeah, thank you for the introduction there, and thanks to John for that fantastic talk. And I put it in the comments there. John, is this the first time you've given this talk, or second, but first time in public?
Yeah, I did the Northern group a couple of weeks back, and
Right.
I did one internally that, you know, it's, yeah.
Yeah, congrats.
A lot.
Awesome. Yeah, and I know you're going to come and give it at my user group as well, aren't you? At Not So IoT next month, in fact, which I still need to put onto Meetup. Otherwise, it'll just be me and you. But I can cope with that. So yeah, a little bit about me. So yeah, Imran was right. I do a lot of different things. So I'm a Microsoftie primarily. So yeah, and I'm an Azure MVP, a Microsoft certified trainer, a Pluralsight author as well, and I've written quite a few courses around the Microsoft IoT Developer Certification Exam, AZ220, which you'll find on there. I know John and a few other people have been through that, so they seem to work. I helped create the exam, so that puts me in a position there to be able to write that content. Which is good. I've been doing this for years, but must be, well, I mean, I had a Spectrum when I was like 7, so there's that. But professionally, I've been doing this for a couple of decades now. So 10 years working for a change machine manufacturer and 10 years, 11 years now working for myself doing this sort of stuff. So it's good. I run some meetups as well. So I run Not So IoT, which if you're into IoT and you've enjoyed tonight, then go and check that out. We're on Twitter and Meetup. I also run, along with Gosha Borcheska, NotStev Workshop, which is an in-person meetup. So since COVID, we've not been running that, but that's about workshop-based learning rather than just listening to a speaker. So getting people involved in actually doing rather than just listening. I also co-organise .NET Knots with Jess White, and we love that. So there's a bit of a crossover tonight with my talk because there's .NET and IoT. I'm also a STEM ambassador and a code club organizer and a public speaker, as you can see here. And I like to blog as well, so go and check petecodes.co.uk for a bunch of blogs. I've written a bunch of stuff about the Azure Percept recently, so on the AIoT spectrum that John was just talking about there. So if you're interested in the Percept, then you can go and check that out. So that is enough about me because now I have only got about 5 minutes left. So tonight we'll talk, I mean, I'm going to briefly go through this because actually .NET 5, it's old hat now because we're on .NET 6. But I've been doing this talk for a little while now. Obviously, there was a release cadence for .NET that's yearly. So I'm waiting for .NET 6 to bed itself in before I move everything across. Time, too busy buying IoT kit. So yeah, we'll talk about .NET 5, what that does, how we get that installed on a Raspberry Pi, and then we'll do some Hello World stuff and run through and build ourselves up. And along the way, we'll talk about GPIO, which I'll explain what that is in a bit, and how we can control that with C#, and then how we can build on other people's code with the device bindings to be able to drive things like servos. And then we'll look on at Blazor and SignalR, and then some final demos outwards from that, and then Q&A if it's not already 10:30 at that point. So .NET 5 is a facility these days since .NET Core to be able to make code that's going to run on any platform whatsoever, from desktops obviously and through web and the cloud, all the way through to AI and IoT there, second from the right, which is nice from us. We've got some new stuff in .NET 5 and we'll get more new stuff in .NET 6. But obviously open source and cross-platform, including the Pi, is a boon. We get some nice C# language features in C# 9 with records and then init-only properties where we can go from many lines of code there down to a couple of lines of code, which is nice. Pattern matching, which is really great on types there. I like that feature there. Top level programs where we can go from not many lines of code, but we spoke about languages where you could have a single line of code to get going. So top level programs allow you to get close to that. So this is a methodology Microsoft are trying to do to get more new programmers into programming. And then we get new things like system.text.json, which makes James Newton King a little bit upset because we're not going to use his library anymore. But interestingly, a lot of stuff just doesn't default to that. It still defaults to that Newtonsoft JSON library. So I find that interesting. I'm not going to go through all the words on here. This came out of Build 2020, so a little while back now. But the one I do want to call out there follows on from what I was just saying about new programmers. 40% of new people to .NET students, which I really like because this ecosystem relies on people using it, of course. And one of the historical problems we've had with the .NET ecosystem is that students weren't taught .NET. They were taught C or Python now, and they are still taught those things, but .NET is creeping its way into academic institutions, which is it's really good because they leave their universities or colleges and they go on to a job and they already know .NET potentially, and that's only going to make that whole ecosystem better. Excuse me. So, how do we get .NET installed on a Raspberry Pi? Now, before this stuff started getting embedded in, then we would have quite a lot of steps actually to go through. But I've created a single line install script. So you just call that single line and it will go through all those steps for you, which you can see animated in that nice GIF at the bottom. Now, if you're not sort of au fait with Linux or particularly comfortable with working in the command line, then some of this was a little bit out people's depth. And for the Debian Raspberry Pi OS, there wasn't an apt get install for .NET. Now there is for Ubuntu, for 64-bit Ubuntu, and of course you can put that on your Pi. But a lot of people just like using Raspberry Pi OS. Now this is at the moment just a 32-bit flavor. I've not made the 64-bit equivalent for it. I just, again, need more time. Or Minions. So if anybody fancies making a pull request for that, then by all means do. I know some people are actually helping me with the .NET Core version of this to make it automatically pull the latest version. This version of this script for .NET 5 will always install the latest version, which is nice. And I had a bit of help with that as well. So that's great. So the first thing you want to do once you've got .NET installed on your Pi is a console app. So if I move sideways and give you a little brief look at, a spoiler look at what we'll be doing in a bit. So that's the robot arm we'll be looking at. And there's a little circuit board down here with an LED and a button. But if I switch to the terminal, so I've got a terminal session working here. If I do .NET --info, then we should have information about the version of .NET. Now, I've not done an install on here for a little bit, so I'm probably a bit behind on my version of .NET 5. But you can see this is the standard thing that you should do just to make sure that you've got .NET installed. But this doesn't necessarily prove that it's working. And one of the things you have to remember to do after you've installed it is to reboot your Pi so that everything falls into place. But once you have, then you can do a .NET new console, and I can put that in Hello World. And that will spin up a Hello World project. Now, this is a .NET, this is a Pi 4 that I'm using here, the 4 GB Pi 4. So actually, it's pretty fast. It's way faster than the Pi 3, but it's not your desktop computer. So nothing I'm going to be demonstrating on here is going to run at the same speed as a desktop PC. It won't. Let's wait for a Pi 5 and get closer, I think. But it's fast enough. But if you go back to a Pi 3, then this starts getting a little bit slower. So this can be a reason for not using .NET if you go back, but what you're not really supposed to do is what I'm demoing here and do any form of development on the Pi. That just makes this whole demo easier for me to do. And I've got blog posts out there that actually show you how you can do all of your development on the PC and deploy the code down to the Pi automatically. And in fact, you can debug it directly from VS Code on your PC and run it on the Pi. But I'm not going to do any of that today because, I've not got all night. So if I cd into Hello World there and then do a .NET run, then we should get the standard Hello World message, which I like actually. So again, you see, that's not a very complicated program, but it does take a little while for it to do what it needs to do, build that package up. But there we have Hello World working. And that's a really sensible thing to do. And it's dead easy to do that. You've not had to write any code whatsoever to prove that you've got .NET installed properly. So that's great. But we're not going to go in there. We're going to go in the RPi robot directory. So if I switch back to my slides, we will talk a little bit about .NET Core and GPIO. So GPIO is a general purpose input-output, and this is all of the little pins on the side of your Raspberry Pi that allow you to be able to connect devices to it, to read things in and send things out, control LEDs, read buttons and things like that. But it does more than that, of course. It allows us to be able to control serial ports as well, to be able to read information from connected devices in a more complicated manner. This Pi and the .NET runtime will use the system.device.gpio NuGet package to be able to do that. So again, somebody else's code, Just like if you were to do this in Node, you'd use a package for that. So Microsoft have got a fantastic package that supports all of the GPIO out of the box, the basic functionality. There's more, which we'll see in a bit. It actually supports Windows 10 as well as Linux, this GPIO library. So Windows 10 IoT, if you've heard of that, is a special flavor of Windows 10 aimed at the Raspberry Pi that allows us to be able to run XAML applications. It's not something I recommend people use anymore. I don't think there's any support there for it. And in fact, you'll see later on, or at least I'll briefly mention later on, that there's other things that we can use in its place anyway. And again, with any NuGet package, you can either install it with the package manager if you wanted to, or just directly on the CLI. Easy peasy. So what's GPIO in a bit more detail? So again, it's the pins on the side of the Pi. If we zoom in a little bit, you can see that we have things like power and just BCM ports labeled on the side. You can see some of them are labeled with TX and RX. Now there's two different numbering schemes to bear in mind with these pins. Obviously, we need to know the number that we can connect these devices to, the number of the pin. So you can see the number closest to the board there, to the pins, that's the board numbering scheme. And then there's this BCM numbering scheme. Now that's referring to the BCM chip that's driving the GPIO. And I really class that as a legacy numbering scheme, not something I'd recommend that you'd use particularly, because now you've got to convert from that BCM number into an actual pin number and then use that in your code. So just stick with the board numbering scheme. But it's important to call that out because we'll use that in the code in a bit. So the circuit I showed you there on that photo, this first version of it here, where I've just got an LED, a resistor and a button connected up to the Pi. This is the standard IoT Hello World, unless you're going to buy, a pre-made thing like a microbit or maybe that microchip device. If you're going to start wiring something up, then you'll have an LED that you're going to turn on and off, and a button that you're going to read in to do something. Once you've got that far, then you're happy. So just to show you what I've got connected where, so I've got one side of the LED through a button connected to pin 10. And again, this will be important when we look at the code. And the other side's connected down to ground. Then I've got a button connected to pin 26 here and the other side connected down to ground. Now, I'll explain a little bit after this screen, but you'll notice there's no resistor for the button. And if you know anything about electronics, then you'd imagine that you'd need some form of what's called a pull-up resistor. But actually, we can solve that in code. But we'll come back to that, and there's some quirks with what we do with that. So, hello world again. So if I switch back over to here, and then I get my code open and pull that onto the screen. I'm not going to write any code tonight because I'm not brave enough. I'm going to paste one line of code into one file later on. But everything I'm going to do is all on GitHub, and I've just got branches, and I'm going to step my way through to the fully built example at the end, and I'm just going to explain how it works. No one wants to sit there watching me miss semicolons and mistype things. It's just not fun. So shout if you want me to zoom in. I'll zoom in just a little bit more, just to give you a little bit more of a chance. At the top of this particular code, and this is just my hello world that I've added some code to, by the way. Thanks, John. He says that's okay. So what I've done is I've brought in that system.device.gpio NuGet package. And in actual fact, we can see that as well in the CS proj file down here. So we've included that. So we've done a .NET add package system.device.gpio to get that into our application. And then I've also got threading, because what we're going to do with this is turn an LED on and off and on and off, and we'll need a delay between turning it on and off and back on again. Otherwise it's just going to be going too fast, you'll not be able to see anything. So we bring threading in for that. Then I've got my main part of my application, and then down here on line 12 we've got hello world, and I'll leave that in because specifically for the next example where we're reading a button, you don't necessarily know when the application started if you've not written any console logging in there. So I leave hello world in there so I know that the application has got to a point where I can start it, especially on a Pi when it's slower. So that's what that line stays in there for. You'll see that all the way through. Next up, we're using this Gpio controller. So we're creating a new controller, and we are passing in the pin numbering scheme of board. So if you remember earlier, that was those two different board numbering pin numbering schemes. We could use BCM there, but just don't. It's just not worth your time. Then a little bit further down, we're going to create some variables. We're going to put pin 10 for our LED here. So if you remember from the diagram there, we've got our LED connected to pin 10. So that's what that means. And then we've got a time in milliseconds in between turning the LED on and back off again. And that's what this variable's for. Next up, we've got the controller that we created earlier. We open a pin and we pass in our pin of pin 10 here. And we set it as an output because we're going to be driving out the LED to turn it on and back off again. So that's what that's doing there. And then down here, I've got a simple while loop. So that's just going to go forever. And that same controller, we write to the pin a value of high, which is going to turn the LED on. So high would be true, would be 1. And then we wait for that light time of 300 milliseconds. And then again, we write to that pin a value of low to turn it back off again. And then we wait for 300 milliseconds and go around that loop forever. And then here, in this finally loop, we just close the pin because that's good practice. You'll notice I don't always do that, but I just wanted to include that because that's really what you should be doing if you finish with the pin. Otherwise, you can end up with conflicts. So let's run that up. Annoyingly, when you're showing the screen, you lose the little white dash across the bottom of your taskbar, so I get blindness then, I can't see it. But if we do a .NET run on that and let that, in fact, it would help. What we go? Hey, what? Oh, different things in here, and I must make sure that I'm in the robot firmware directory, and that would help to actually run the application. So let's clear that and do a .NET run instead. .NET run. This is why I'm not live coding. I can't even type simple commands into the terminal window. So let that finish up and then we should see Hello World appear. And then what I've got is I've got my Surface Pro down here. So like John, I've got multiple cameras set up down here. So if I bring that on the screen, then you can see down here, and I know it's reasonably small, but you can see the LED is nicely flashing. So that is turning the LED on and back off just with that controller write, that pin write there. So that's pretty straightforward, but that is your hello world of IoT, and that's the end of my talk. Bye. That's definitely where you start, though. Flashing an LED is just synonymous with any form of beginning IoT, and I like that. So that's that. So I stopped that piece of code, but you also saw on that screen that we have a button, and we went through that circuit. So the next part that we need to do is read that button. So if I switch back to my code, then this might complain, but we'll see. If I scroll down here, then I've got the next part is 7 for read button, and that will switch. And if I go back to the top of the code, I'll go through what I've done. So we've still got the same using statements at the top, but further down here, we've got an extra variable for our button, which is on pin 26, you can see on the diagram. And then we open the same output pin for our LED. And then next, we've got an open pin as an input pull-up. Now, if I go back again to that circuit diagram, as I say, there's no pull-up. Now, what happens with buttons and connecting them to devices is that the pins often on IoT devices will be something called open collector outputs. Now, what that means is that when you connect something to it, it kind of just floats around at a level which may be high or may be low, just depending on how it's feeling and the temperature and things like that. So ordinarily what you would do with any button or device like that you're going to connect is that you'd tie it to a level that you'd know, and then you'd press the button and that would connect that pin then to a low or a high. It depends. So you can either pull it up or pull it down. So that's great. So that's a resistor, but you don't actually need to do that because inside of the Pi, you can turn on these pull-ups. And the fact that I've pulled that up means that when I'm not pressing the button, it's going to be high. And this is important to recognize because actually the logic's going to seem backwards at this point because I'm not pressing the button. So when I read that pin in, it's going to give me a 1, which is great. And when I press it, it's going to give me a low, a 0. So if you'll see here in the code, if I scroll down, I read the button pin, and if it's false, if it's low, if it's 0, then I turn the button on, turn the LED on rather. So it's going to seem a bit backwards. So the button's off, but I'm turning it on. But that's just how the electronics are wired up there. just in case you wondered that. But essentially, I press the button and I light the LED. I don't press the button and I don't light the LED. So the code is pretty simple. And again, I close the LED pin. You'll see I've not actually closed the button pin, but you know, for this demo, we don't need that. So with that working, let's run that back up again. That finished running. Hello world. Switch back over to our image. And then if I press the button, then, and it's not coming on. Oh, there we are, it is coming on. There we are. It was just not quite pressed in properly. So yeah, so that is a really expensive way to connect a button to an LED. I've stuck a Raspberry Pi and a bunch of cables and a breadboard and all sorts in the way of that. But now we're at the point where we're controlling outputs and reading inputs. And, you know, you really are on your way now with IoT at that point. So yeah, you've got to be happy with how that's working at that stage. So I'm just going to stop the code and go back to the slides. And this next part we'll talk about is some more code. So we've got the GPIO NuGet package that we're using, and that gives us access to the raw functionality on the Raspberry Pi's pins, inputs, outputs, serial ports, PWM and stuff like that. But if you want to connect up some devices to that, then you might have to write your own code to actually control them. I know LED or a button, that's pretty simple stuff. But when you start sticking things on there like IO expanders, then having somebody else's code is great. And that's what this IoT.device.bindings NuGet package gives us, is a whole heap of code for controlling devices that somebody else has written, mostly at Microsoft actually. So you know that this code is going to be half decent. And there's code in there that allows you to be able to read temperature humidity sensor, BME280. Cliff, Aegis and I, that's our favorite knot. Cliff actually hates all the IoT demos tend to have that as your next step after you've read a button and flashed an LED. You'll be reading temperature and humidity, mainly because those things are cheap. Those little BME280s or the equivalent, I think DH11s or whatever they're called, that read temperature and humidity, they're cheap as chips and dead easy to hook up. So it's a good thing to use. And then when you go onto the cloud side of things, it's great because you can plot that sort of stuff on a graph, and yeah, just it makes sense. But yeah, a little boring because everybody does it. But you can also control things like IO expanders. So there's obviously a lot of IO on a Raspberry Pi, but there could be that you needed to read 20, 30 buttons in, so you can have IO expanders for that. It'll also drive the HATs, the hardware attached on top devices for the Raspberry Pi. So if you've never seen it, then Tim Peake took up 2 Raspberry Pis, and they had this Sense hat that you can see mentioned there on there in a nice box, and that gives you things like temperature and humidity, obviously, magnetometer and a little display, a couple of buttons, gyroscope. And what that project AstroPi allows people to be able to do is that students can write code that runs on the space station and then get the results back, which is an amazing thing to be able to tell somebody. If you want to get somebody into IoT, tell them it's going to run in space, and you know, you don't have to be a child for that to be cool. I like that. But one of the other things it's got in there is a servo control library, which is great. I'm going to talk about servos in a little bit. So the actual circuit that I've got wired up here, the bigger picture to this circuit you can see here. So you see at the right in the middle there, I've sort of gone off of this board. So there's a board called a Servo 6 board, and that's going to control my robot essentially. And the reason why I've used this is because these little servos, which are like motors, they take quite a lot of current, and while you might get away with connecting one to a Raspberry Pi, I wouldn't recommend you try and do anything much more than that, and I wouldn't even recommend you connect one directly to it, because it can take half an amp when it starts up or if it stalls. And I think the Raspberry Pi is only spec'd at something like 100 milliamps or something to source out current. So yeah, this Servo 6 board, it's got a battery pack attached to it that deals with just the power side, and it leaves just the control on the Raspberry Pi. So what you can see on this end is the control wires. So each servo, and I've got 3 on this particular robot arm, gets its own control wire, and then there's a ground. So if I zoom in a little bit, we can see here the ground is on pin 25. Now, if you do buy this Servo 6 board, I made the mistake when I first bought it of missing the fact that that first pin was actually ground. I thought it was channel 1, just because of the labeling. I don't particularly like that labeling. I think that could have been done better. But that first pin is ground, 0 volts. You're going to need that because you need to be able to make sure that you close that circuit with the Raspberry Pi. Next up, we've got channel 1 connected to pin 35. And then we've got channel 2 connected to pin 13. Now, the Raspberry Pi has got 2 hardware PWM ports. And I'll talk about PWM in a minute, but it's got 2 of those. And that's what those 2 are, 13 and 35. But we've also got pin 12 connected, because we can actually do some of this control in software thanks to this library. I'll go into a bit more detail on that. On the other end of that Servo 6 board, we've got the servos, those 3 servos I was talking about. And you can see that there's 3 different coloured wires, yellow, red and black. Depending on the servo you buy, that could be slightly different colouring. It could be orange, brown and black. But you'll know that the black one, and they'll come with a connector, will go on one side, and you need to look. You won't be able to see it very easily, but actually there's a minus and a control and a plus on those pins. So long as you can get minus and black lined up, then you'll be good to go. So I've got 3 of those all connected together, so control, power and ground that way round. Now, servos are like a little motor, if you will. And my robot arm, this little motor is constrained to 120 degrees. And it's moved and positioned by something called pulse width modulation. So what happens is when you send a pulse to that control line, if you make it a little pulse with a big gap in between, then it will go one direction. And if you make it sort of a normal pulse with a normal pulse gap in between, then it will go to another position. And if you give it a big long pulse with a small gap in between, then it'll go to another position. And it keeps firing those pulses there and keeps it in that position. So it's kind of floating. But that's great, because if you imagine your robot arm and you want to move it to a position, that's exactly what you want to do. And for the most part, you don't want that whole thing to spin 360 degrees either. 180 degrees is going to be enough. Even the base, if you think about it rotating with the wires attached to it, the last thing you want is for it to keep turning round and round and round. So that's the basic idea of that. So servos, let's have a look and make that work. So if we go back to here, if I quickly just show you again the robot. So this is a top-down view. I'm using something called an Iot cam, which is a 4K cam for presenting stuff like this. It's aimed at schools actually, but it's great for this. I've not got enough good words to say about that camera. Go and check it out. But anyway, it's pointing straight down on the top of my robot here, and there's 3 servos. You can see 2 of them. There's one in the base. And I made a fatal mistake when I put this together, and I didn't screw the base and the servo down, and so it's a wobbly robot arm, but I like that. It gives it character. Next up, this top one here, that's controlling the reach of the robot arm, so it moves in and out. And then this top one here, that's controlling these 2 grippers, so the grab, if you will, for the robot arm. So that's the 3 angles of momentum that we can get out of that. So it can rotate around, and it can reach in and out, and it can grab things. So let's switch back to the code, and we'll switch to the servo control, move servos here. And I'll scroll up and I'll show you how this particular piece of code is working, and then I'll run it. So we've still got these standard 3 usings here, so GPIO and threading. But what I've done is I've brought in PWM, and this is from the device, the GPIO library. And then we've got the drivers for that PWM. But then we've brought in servo motor, and that's from that device bindings NuGet package. So the GPIO NuGet package knows how to deal with PWM, great. And then the IoT device bindings library, that's got code in there to actually deal with the servo motor. So if you imagine PWM is great, but when we go through this, you'll see that it's a bit more complicated than you'd imagine. We've got our hello world, because we always like that. So the first new line we've got here is we create a PWM channel, and we pass in a few things here. And the first one is the chip number. Now there's only 1 chip on the Raspberry Pi for PWM, so that stays at a 0 indexing. And the next is the PWM channel. And again, I mentioned there was 2 hardware channels, so we start at 0 for that. And then we pass in a frequency of 50 hertz there, and that's what that first line is doing, is hooking up the PWM, that pulse width modulation. Next up, we create the servo motor, and that's come from the device bindings again. And we pass in our PWM channel that we've created above. We tell it what the maximum angle is, and these are 180-degree servos. And then we've got the minimum and maximum pulse width. Now, I've just bought really cheap, like S310 servos, I think they're called, or something, from Amazon. They're like £1 for a 10 pack or whatever. They're dead cheap, but they're not repeatable. So it's possible that you might not get it to move all the way, and so you can fiddle with these numbers to be able to make that happen. I think I've just left these as the default, and they just worked, which is great if that works for you. But if it doesn't quite do what you want, then try moving those a few and see what that does. We do that whole thing again for a second PWM channel. The only difference is we pass a 1 in to the PWM channel number, and we've spun up a second servo off of the back of that. Now, again, as I was saying, there's only 2 hardware PWM channels. Now, doing that timing and getting it to be rock solid is hard. So that's where hardware PWM comes in. You just point it at a frequency, and it just handles that in the background. Now, if you've got an operating system running on top of this, which we've got Raspberry Pi OS running on top of that, doing any strict timing is difficult. And when I first gave this talk, I had no solution to that problem for my third servo. And I know John, when he first started playing with it, that's the point we're at. And it was great enough for the gripper to be able to do this in software, but it literally went on off. So you had grab or don't grab, nothing in between. So I attached that to the gripper and just told people that's how it was. But after a little bit of digging and some help with the Discord channel for this .NET device bindings, we found out that we can use the software PWM channel, which I was using anyway, but all you need to do is add this true part to the end, which puts it into a high accuracy timer mode. And now we can do software PWM exactly the same as hardware PWM. So that gave me the facility then to be able to have my third servo from the very bottom arm, which is great. The slight difference in what we're creating here is obviously the software PWM channel is actually coming from the device bindings library again. But we're also passing in the pin number we want to use as the software PWM. If you remember, we've got 3 different pins, and pin 27 is what we're using for that. We've still got the same frequency, and then that's a pulse width that we're passing in there as well, I think, for that 0.5, can't quite remember. And after that, it's all the same. We create our servo motor when we pass in now our software PWM channel, and everything else works the same. It's 180 degrees, and I slightly fiddled with these. I don't think I needed to, actually. That was actually during the period of why can't I get this to work properly. And now with this super high accuracy mode, I think I could have popped them back to exactly as they were. Doesn't make any odds. Next up, we actually start the servo motors up. So that's important because, as I mentioned before, it constantly sends those pulses to it to keep it floating there. So that's what this process does with the start. And you'll know when you've done that because it actually buzzes because it's floating and it's kind of sitting there doing that. You'll hear it buzz. And one of the things I'm going to do is remember to plug my batteries in at this point. And hopefully the batteries are okay. If not, I've got some spares, but I don't really want to have to swap them. So we've started all 3 servo motors up, so they're going to sit there energized. Next, we've got a while loop. Now, I've got at the bottom here, I've got a little routine that I pass a servo into in an angle, and it takes that servo and it writes an angle to it. So I could have just got by, but you'll see I use that later on. So that servo is the servo we are creating at the top essentially, but passed into this routine. So if I start here again, so we move to an angle and we pass in servo motor 1 and we tell it to move to 70 degrees. Can you run that servo hat on 12 volts? Probably, I want to say, but I think it has actually got a voltage regulator on it, so I'm not sure if it'll do actual 12 volt servos, but I've got 4 batteries on there, so I'm only running mine at 5 volts, there or thereabouts. I've not looked, but actually you don't need that board. It just makes life easier, that board. You can do this with a piece of Vera board and then power it how you like. Just make sure that you're taking the power not from the Pi, but from whatever power source you like. I just liked it because it was a bit neater. And I was using it for a workshop, and I didn't want to expect people to start wiring stuff up. There wouldn't have been time. So that's that. Anyway, we move to an angle. We pass in servo motor 1, and we tell it to go to 70 degrees. and then we wait for 2 seconds, and then servo motor 2, I tell it to go to 20 degrees, and so on and so forth. So what I've got here is a little servo dance that's going to go backwards and forwards and exercise all of my servos in a loop forever until I tell it to stop. And then when I do, then I do actually stop it, so it releases that servo control. And one of the important things with that is that if you leave the servos all connected and sending those pulses, it will keep it in that position. It's not going to want to move it, and you'll just destroy the gears. When you stop those servos, then it becomes fluid, and you can actually move the robot arm yourself back into a position. Looks like there's a data sheet for that Servo 6. So yeah, well done, John. Thank you. And there we're back at the bottom here with our angle. So there's not much code there. Really, the crux of it is that we create some servos and we write an angle to them. And that's what the beauty of this device bindings code is. We've not needed to worry about pulse widths and timings and stuff like that. It's been done for us, and I'm all for that. Other people's code is great. It's like other people's money, especially if they're buying all the IoT kit. So yeah, do that as much as you possibly can. So that's how that code works. So let's run that up. And this is where I hope my batteries are okay. And I'm going to switch over to this. And I'm going to hold on to it because it might get excited. Oh, there we go. And there's our robot arm moving away. So you can see it's actually, I think actually it's the batteries are running a little bit low, but it's doing all right. It's not bad. Yeah, so at that point, we've got a robot arm moving. Yeah, it's boring. But it's actually moving at this point, so you could just stop at that stage. And obviously I started with this, and my original version of this talk was going to be about that, but I thought I don't really want to have to stop there. I want to control it myself, but I didn't want to sit there with the console app typing in numbers, because that was boring as well. So let me just stop this code and switch back to my slides. We've done the servo demo. What I thought would be good is if we could hook it up to a web app. And so obviously if you're in the Microsoft ecosystem and you want to use something slightly newer, then for that we're going to use Blazor. So Blazor, if you don't know, is a single page app framework for building client-side web applications. Actually, it started life as a pet project for this guy, Steve Sanderson. He went and demoed it at a, oh, okay, thanks for coming, Aidan, appreciate it. He demoed it at a Microsoft conference, and a few Microsofties saw it and went, oh, this is fantastic. We need to have that. And ever since then, it's come on leaps and bounds. The crux of it is that you do your web development in C# rather than JavaScript, which is powerful, because if you are .NET house, then you don't have to have that JavaScript knowledge set in the house anymore, theoretically. That's a lie, really, because there's still stuff that you can't do at the moment, and so you're going to have to rely back on that JavaScript stuff. But for the most part, you can just get away with just using C#. You're still doing Razor and HTML. So if you've used ASP.NET, that's what that's come from, Razor markup language, and it's very, very similar to that. So if you're a classic ASP programmer, then you're gonna be in a good place here, on ASP.NET rather. Then you can come and try Blazor out, and you'll feel reasonably at home. There are a few different flavors. Actually, this is a lie, but server-side and client-side WebAssembly are the main flavors. There are a bunch of projects on the side, including desktop applications and mobile applications and stuff like that, that are cracking off alongside this. But as far as the big players, then we've got server-side and client-side. So server-side is running essentially a thin client in your browser, and using Signal R, which we'll come to in a bit, it orchestrates the DOM, the document object model updates, from a server object running in the cloud. So this little server application has got all of your important code in it, and all your browser is doing is just saying, okay, I can update the DOM to do what you want me to do with it, and oh, by the way, here's a click event on a button. That model is great for circumstances where you don't want to leak code out, because most of your important private code can live in a little silo in the cloud and can't be got at. So quite handy for that sort of thing. But any new modern web development, WebAssembly is where you want to go. And so we offload all of our processing that we're paying for in the cloud down onto the client's browser and make it work down there. And we can do this all in C#, which is fantastic, mega fast as well, works offline, whereas the server one, of course, you need the server, so that doesn't work offline. And this is all done without plugins. There's no plugin required. The stuff that runs in your browser there, WebAssembly, that's using actual .NET DLLs, as they would be. It runs a little VM, essentially, and runs your code. It's not proper assembled bytecode at the moment, although there's a version for that coming. But it's running actual .NET code with .NET DLLs in your browser, which is cool. And supported with everything these days, everything that's important anyway. So if you know me and you've watched any of my talks or what I go on about, I'm usually talking about IoT Hub or something like that. And I could have used that for this job, but what I wanted was real time. And that's what SignalR gives us. So SignalR is a library for ASP.NET developers that gives us real-time web functionality between points. So this is an open source initiative created by David Fowler and Damien Edwards way back in 2011. And that's old in .NET terms, which means that you can just go ahead and use this. It's well bedded in, well known. And enables us this bi-directional communications. If you imagine a chat app, and in fact we'll talk about that in a bit, that's sort of the hello world for SignalR will be that. And it supports everything from WebSockets, which is the de facto standard for this. But if you can't do WebSockets because perhaps you've got ports blocked, then it can drop down to server sent events or even long polling. It'll automatically do that in the background. It's great. So we need to drive the arm with our Blazor project. So what I'm going to do is switch over here, and then I'm going to switch my code right to the very end of all of this. So I'm going to go back to my main. I'd go through and I'd explain the steps along the way, but I don't think we need to do that. So I'm just going to explain some of the stuff that we've got going on in here. A lot of this is exactly the same at the top. So we've still got PWM, we've still got threading, and there's no GPIO anymore because I've not actually needed that, but we've got the PWM stuff sitting there that's off that same library. But we brought in SignalR and HTTP because this is going to go over HTTP and we need SignalR to make that work. So down here we create what's called a hub connection. So this is what's going to connect to our SignalR hub. So there's going to be a single service that sits in the middle of what's called the clients and orchestrates the messaging between them. It's like just a man in the middle, essentially. So you can have multiple clients all connected to that same hub, and then you can send a message to the hub and it can send it out to all the other clients. So that's sort of how that topology is working. A little bit further down, we've got those same Pwm channels that we created before, including the software one. And we start them up. But then down here on line 47 onwards, we use this hub connection builder to connect out to a URL, which happens to be a URL on my PC because I'm going to be running this locally. And we pass in a configuration here. Now, I've needed to do this because this is going to run on the Pi. And for some reason, and I'm sure that there's many different ways of fixing this, but I couldn't figure it out and I couldn't be bothered. It was just rejecting the certificate that my PC had. The Raspberry Pi was just saying I'm not connecting over that. And I've read loads of blog posts, including clearing certificates and resetting stuff, and I couldn't get it to work. And so I decided to do something dangerous. And it says it's dangerous, look, to accept any server certificate. So don't do this for production. Not a good idea. But for this particular demo, that just gets me over that hump. So don't burn me alive. That's what I'm doing. I'm not a security expert, and this doesn't need to be. Next, we do this with automatic reconnect. Now, with any real-time application, the last thing you want is for it to drop its connection and never reconnect. So with one single line of code there, and we get it to automatically handle disconnects and reconnects, which is nice. And then we build it. So that just builds that whole connection up and off it goes. Now, a little bit further down here, what I'm doing is the connection, building that up, and I'm triggering from a message. So this is a message-based system. And again, if you remember the chat application that I mentioned to you earlier, in that particular scenario, we would have a user and they would send a message. And so I've usurped that So the user, in my case, will be the servo I want to control, and the message will be the angle. So I'm sending a message out, and actually it sends out a received message. It's going to seem a bit backwards, but when I show you the web code, you'll understand why. And then it passes in this user, which is the servo, and the message, which is the angle. And I've just got a simple if statement set up here. So if the user is servo 1, then I move servo 1 to the message angle, essentially, and the same for servo 2 and the same for servo 3. And then I just console write out that result so we can see it happening. And then underneath all of that, once I've actually set that message handling up, then I start up my connection, and that handles then the authorization and connection out to our hub. And then I've just got a while loop down here because otherwise it would stop after that, which is no good. And then when my while loop's finished, then I just stop the motors again, the servo motors, and off I go. And there's my normal move to angle. Now, if I scroll across here, then this is the web app running on the screen just here. And if I get the code for the web side of it, then we can understand a little bit about how that's working. So if I put that code back, the UI back on the screen, you see we've got 3 sliders, and I liked sliders actually because they give you some fine control rather than again typing into a text box or pressing it up and down or selecting a version a value between 0 and 100 from a drop down box. Why not just do that? So I liked that. So that's the UI that we're aiming for with this particular bit of code. To add Signal R to a Blazor app, by the way, there's a few things you need to do. You need to in the startup here, there's a few things that you need to add. So we add Signal R to the services here. Don't worry too much about this. There's loads of blog posts out there to help you with that. And then down here, we can add an endpoint, and that just tells us there where that chat hub actually is, so that the web application, as you saw there, so that can connect to it. So again, for the topology, we've got a Raspberry Pi, and that's going to connect out to my PC, which is where the Signal R chat hub is running. And then I've got a web application written in Blazor that's also going to connect to that Signal R chat hub that sits in the middle of all of this communications. So I'm going to move those sliders, and it's going to send messages to the Signal R chat hub that are then going to get sent to the Raspberry Pi. And we can see that in the code actually. So if I scroll up to the top, we've got some bits of stuff you need to add. So the Signal R client, which is the same Signal R client that we're using down on the Raspberry Pi. And then I've got some HTML set up, and I'm binding some stuff to that. So here's my sliders just there. I'm using this mat slider, this mat Blazor library happens to have sliders in there. It's great. Go and check it out as a link in the slides at the end. And I'm binding a value to a property here, and we don't need to worry too much about all of the rest of that. That's just setting up what the slider is going to look like and how it's going to work. And I've got 3 of them, and then I'm also going to spit out the messages I'm sending to the Signal R chat hub. Then down here we've got our hub connection, which is very similar to what we had on the Raspberry Pi, our list of messages that we're squirting out onto the screen. And then when the page starts, we do the same thing that we were doing on the Raspberry Pi. We connect to that chat hub, but instead of having an IP address that you saw in that previous code, we just do /chat hub because it's living at the same place. It's on the PC. And then here, the same thing. We're reacting to a receive message, and we're just going to stick that out onto the screen, and then we start that hub connection up, and that's connected then at that point. I've actually got a Boolean here to know whether it's connected, because if I wanted to, I can expand this and turn off controls if the Signal R's dropped out for whatever reason. Hard work, as it's on the same machine, but you know what I mean. Then a bit further down, we've got some properties, and these are what I was binding those sliders to. So you move the slider, and it changes the value of this property. And when that value changes, I use that hub connection, and I send out a message called send message, and then I pass in the user, as it will, the servo number that I'm controlling, and then the servo 1 value, the value of this particular property, so the value of my slider, and I just make that a string. So I do that 3 times, 3 different servos down here, and then all I do is, new them up to a known position, so I know what it's doing. The chat hub, by the way, so this is the crux of the Signal R. There's not much in here. all it is a basic class, and I've got that send message function in here. So that's mapping. So when you call send message, when it calls into here, just by convention, it finds that send message task here, and then it picks up the user and the message, and then I'm sending receive message out. So this is where that receive message was appearing in the code for the Raspberry Pi there. And I just pass in the user and the message, and then that goes down to the Raspberry Pi, it picks it up, and it should do what you need it to do. So I've already got the web app running that you saw there, and I've got my camera pointed at the robot arm, which is great. But now I just need to run the code up, and I think I've got the on here, so I'm just going to run that up. Go back to this, and then all being well, you should see a little jerk on the robot arm if this works. There we are, a little jerk. The batteries aren't great, you know, they are. That usually would go a lot jerkier than that. But now I can drag these around and I can move my servo, which is moving the whole robot arm. So that is real-time control of a robot arm from Blazor down to a Raspberry Pi, and all in C# essentially. So that's the little gripper there, and I can open and close that. And that's the software Pwm one, by the way, and you can see that that's nice and smooth now. It might not look that because, you know, we're sending this over Teams, so yeah, not necessarily ideal. But yes, I mean, that's great. I like that, and I could have stopped there, but I didn't want to stop there. I wanted to go a little bit further. Now, before I do any more, I'm actually just going to stop this code again. That one there, stop that, and go back to my slides again. So we've driven the arm, woohoo, from Blazor, real time, it's dead good. I'm not going to demo this next part, but actually I'm a big advocate of something called Uno platform. Now, we mentioned earlier Windows 10 IoT, and that's great if you want to do XAML stuff, but again, it's not supported, I don't think, really. It's just old, and you're constrained at that particular bit of the platform that they give you access to with that slimmed down version of Windows, so just don't use it. What Uno platform is a universal Windows platform bridge that allows us to be able to run UWP on the Pi, which is fantastic. Obviously, it supports other things there as well. But for us, the Pi is what's interesting. Now, Jerome Laban and his team have created this. It's open source and very much open source, in fact, so much so that Jerome himself every Tuesday night runs a Twitch stream where he does live coding on his own open source project. And it's part of the .NET Foundation. They do some fantastic work. I would normally demo this, but because I've got everything open, when I try and demo remote deploying Uno code down to a Raspberry Pi and a VNC session, it's just one too many things for my Surface Book, and so it just gives up. So you'll just have to believe me. But this thing, it gives you the facility to be able to put UWP apps on the Pi, so you've got graphical applications running on there. Now, if you've tried to do that before, then you'll probably be doing GTK, and if you're lucky, like Mono or something like that, but if not, C. And it was hard. I've done some stuff in that, and it fried my brain when I was trying to do it. And I've done plenty of WPF and Silverlight back in the day, and UWP and stuff like that, Xamarin apps. So I knew how to do that. So when I spotted Uno platform, it was great. That's fantastic, and I leapt straight on it. And with Jerome's actual help, he leapt on a couple of Twitch streams that I did live coding on there, and managed to get a UWP app deployed onto a Raspberry Pi. And you can do all of this stuff with the with Uno platform. So you can write all your C# code and deploy it down to the Raspberry Pi, and you can have sliders. They're not Blazor sliders anymore, they're actual UWP sliders. Move them around and control the Pi directly, so you don't have to go through any of this if you wanted to. You could have just a little Pi controller with maybe a little tiny HDMI touchscreen on there, and you could control your robot arm locally, which, you know, it's just something that's cool. I like that. So no demo for that, sadly. So that's fantastic, but there is one more little step that I thought I'd take you on. So if we go back to this code up here, we're pointing this at the moment to my local machine, but that local machine is running a Blazor app, So Liam Gulliver and I, Liam Gulliver is one of the members of the Agile Engineering podcast and the Azure-ish Twitch channel that we're also a part of. We wrote a talk, a DevOpsy based talk, and we sat down for ages and tried to think how could we make this DevOps talk cool. So we actually deployed that web app to Azure, which sounds sensible. You know, it's quite an easy thing to do actually. So actually, if I change this to point to that, just here, all of this, oh no, not all of that, just there to that point, and save that. If I run that up, and while that's running up, if I scroll across again, over here, we have, if I just maximize that so you can see what it's doing, we have pretty much exactly the same setup as you saw before, only now I've embedded that video in there. And by the way, it is live. There's my hand. Just so you don't think I'm faking it here, by the way. So that's pulling that same video stream in here. And so what I've got here is the exact same application, but running in the cloud. So that we've got that Signal R Hub up in the cloud now, and that actually allows you to control the robot arm from anywhere. And if I paste that in there, then you can actually try this. So go ahead, click that link, and look, some people are doing it already. Now, what I do at this point is put my finger on it because it tends to fall over at this stage and goes all wonky because people do all sorts of funny things with it. But you can see down there the messages that it's sending. If I scroll that down, then they appear at the bottom of the list, sadly. But the first time we demoed this, actually, one of our good friends, Shahid, had moved to New Zealand, and he controlled this robot arm from New Zealand in real time. And it was in real time. It was very little lag between where he was in New Zealand and here. So it was fantastic to be able to see the application for this. Now, yeah, be careful. You'll start hitting the people and things, and many people will die. No, they won't, not really. Just my poor robot arm. I mean, it might seem a bit silly, but actually, have you seen that advert where Kevin Bacon's shaving that actor, I forget what his name is, at the top of the hill? That is very real technology used for medicine, for instance, where surgeons can control a medical robot arm, less wobbly than this one, from across the world, perhaps. But in real time. So we're demonstrating actual usable technology here, although we're doing it in a very Heath Robinson way. But there are applications for this. So it's important to know that you can play with IoT, but actually sometimes there's a path where you can take that and make an actual product out of it, which is nice. And I like that. So I thought I'd stop there, but again, I didn't want to. So if I go back again to here, I added some VR to it. I bought an Oculus Quest 2 headset, and I thought, oh, how cool would it be to be able to control my robot arm from inside VR? It would be cool. So I did. So Unity, the great thing about Unity, and this talk is all about C# pretty much, is you can do this in C#. So it's a cross-platform game development engine, and free as well for the most part, if you don't mind the Unity logo. So it's old now as well. So founded in 2002 by these three clever people, and supports VR headsets nicely, including the Oculus Quest. And we can do it all in C#, and it's .NET Standard 2 and .NET 4 compatible. So I'm not going to go into .NET Standard 2 and .NET 4 and all the differences there, but that allows us to be able to write C# code that we can target onto an Oculus Quest headset, which is just fantastic. That stopped moving. I'm going to assume that people have actually stopped moving it rather than something bad's happened. But oh, that's good. It's still working. That's good. But yeah, we can add NuGet packages to this. Actually, when I was trying to figure out that, it was really complicated trying to add NuGet packages because you pull it in and it pulls all the different flavors of NuGet package for all the different operating systems in, and then you only really need the .NET Standard 2, and you got to copy and paste. Oh, it was a pain. I think Cliff Aegis, when he's done some Unity, actually he knows a better way to do that, but geez, it was complicated. It's about the most complicated part of the whole thing, actually getting the robot arm to move with it. Not as bad as you'd think. So let's demo that, shall we? So if I scroll all the way across, so this is that same BCS demo that we've got working there. But if I pull that off to the side, then over here on the right-hand side, I'll be able to cast my Oculus Quest. So I'm going to have to sort of tip my headphones down here. Actually, I'll take them off. You won't be able to hear me. Rather, I won't be able to hear you. You're going to be able to hear me perfectly well. So put stuff in the chat if something else happens. But there is my Oculus Quest 2. I got the 256 gig version because I like that. So I'm going to put that headset on. And I'm going to grab my controller. And then I'm going to go back to my apps. And get this started up. And while I'm doing that, I will cast my screen to the computer. Next. And all being well on the right-hand side, if it works. Sometimes this can be a bit glitchy, and it did work. We should see. I should be able to see my robot arm there, and I have to kind of lift it up and because it got half a window. So that's my wobbly robot arm, and that is the controls for it. Now, if I move this, it moves the robot arm in there and the real robot arm in the real world, and also the reach and also the grab. Now, the great thing is, if somebody out there wants to try moving the robot arm with them same controls, using the demo, you should see this whole thing move too. So we are controlling a robot arm from VR, but we're also seeing the real world coming into VR. And this is all using the magic of Signal R and C#. And I like that. And all basically made possible with that one Blazor app that's got this Signal R hub sitting in it, because this can talk to it. So it's cool. I like that. And that's about that. So I'm going to stop casting. Doop. Hey, no, you're not. Alexa, stop. Well, you know, it wouldn't be a good IoT talk without Alexa getting involved. So there you go. So that's coming towards the end of my talk. I'll leave that going for a little bit. So if you're on there, then you'll be able to still see it with my hand just there. But I'll go back to my slides. It wasn't all plain sailing, by the way. When I was doing this, my cat took an interest in it. Whenever the sound of these servos, she loved it, and she'd come over immediately. Also, you know, if you don't tie this thing down properly when you're doing it, then it's not ideal. You can move things around and you know, move things too far. And let's just do this one over here, shall we? Yeah, it's one like that. So yeah, but it was good fun while I was doing it. That middle clip there was just the jerky, and in fact, if we go back, I'll show you that. Geez, I have to click it. It's never easy, is it? There we go. Just let that play through. The second clip in that was this before I learnt about the high accuracy PWM. So if you watch, it sort of moves just it doesn't let you do very much with that second one. It just stuck. It's not very good video. Some links here. There's a full GitHub repo here and some workshop instructions. You can build this whole thing. And I know, John, you did this. Did you put the 3D? Did you 3D print the arm? Yes, I did. And the 3D printed robot arm models are in there. And actually, Cliff Aegis, his son, actually, has created a far simpler 3D model. This one that I'm using, quite complicated to put together. Lots and lots of bits. And not very easy, but actually the one that Cliff's son's created is just 3 or 4 parts, and the servos themselves are what's used to actually hook the robot arm together. You just need the screws from the servo packs and screw it together, and off you go. It's dead easy. It's really good. They did a cracking job of that. So I like that. C# 9 and .NET 5, the announcement there. Installing .NET 5 on the Pi. I've got a blog post about how that all works. So if you don't trust the script, and by all means don't trust it, but I've got all of the steps detailed on that blog post. There's some information there about the GPIO, .NET GPIO NuGet package, and also the device binding source code there. If you go to the source code, you can see all the devices. That's why that link's there. The 3D printed robot arm, you can go to that link and get it. So that's the one I'm using. But also, there we are. And John's got V2 of it. It's beefier and it's got different servos. You see the one at the bottom there? That's a bigger, heftier servo. And in fact, John, is that 12-volt one going through the same control board? Is that what it's doing?
Yeah. I got all 4 servos going through. Yeah, the bigger ones. Yeah.
Yeah, perfect. So that's complicated to put together, though, isn't it?
Very.
So, yeah. Whereas the one that
Very.
Cliff's son's done is dead easy. 5 minutes he'd have that thing together. It took me about an hour actually to assemble mine and get it right because it was hard. So that's great. Some information there about Blazor. That Map Blazor open source Blazor controls library. Go and check that out. There's also Awesome Blazor. Go and check that out. There's SignalR. Go and check some information about that. And Uno platform. Definitely go and check that out. If you like watching IoT stuff, then I, along with Johnny Chips, in fact, we appear on the Azurish Live Twitch channel. And in fact, Dean, you're on there as well, aren't you? Every now and again. So by all means, go and check our IoT Live show out. We'll be coming back. We've been on a summer break, by the way. Azurish Live's been, aside from all of our other channels, this particular show has been on summer break, but we will be back soon, and I think we're going to be increasing the number of people actually that are on it presenting. So keep your eyes peeled or your ears peeled for that. I mentioned earlier that I create Pluralsight videos as well. So if you are more interested in taking your learning more professional and you want to learn about the cloud side of things particularly, then the AZ220 Microsoft Azure IoT Developer Specialty Certification, I like big long titles. That exam's fantastic. I know, John, you passed that, and maybe a few other people in the chat have as well. But if you haven't and you want to go and learn how to, then there's a fantastic learning path that I and a bunch of other content creators have created with love and care, and it should give you everything you need along with the docs to be able to pass the exam. So do go and check that out. And in fact, I can get some 30-day codes. If you need a 30-day code for Pluralsight all access rather than a 7-day limited access one, then get in touch, send me a tweet, and I'll make that happen. And with that, I'll leave you with the contact screen. Best place to contact me is Twitter, by the way, Pete, at Pete_codes. The fact that it's underscored, that means you can't see the underscore, but that's what that is. You can email me, but email just gets lost in amongst all of the would you like to transfer £100,000 for me emails. So don't do that. Check my blog out, petecodes.co.uk. Some interesting stuff on there. And again, if you like the meetups, then Knots IoT. We'll be coming back next month with John Lunn giving his same talk. So if you missed it while you were here, then come along and watch it again. It's worth watching twice anyway. There's a lot of information in there. .NET Knots will be back end of September. Not Said Workshop will be back when we can go back to in person. Lati is a Loughborough-based sort of high-tech networking group. So that's that. The Agile Engineering Podcast is there, and Azurish Live. Go and check that out. These slides you can see, they're live at the moment, so you can go and download those there. And with that, I'm knackered. So
great session that was. You know what? I could play with that. Is it still on?
It is. Yeah.
I could play with that one, mate. It's really cool. Are these kind of websites around for kids to jump on and have a go at them live and stuff like that? I've never really come across one.
No, what I saw years ago, actually, one of the first web things I saw was that somebody hooked his lamp up. Now, I've given sessions on this as well, to a microchip embedded board. So Microchip's another IoT manufacturer. And one of the boards that came out when IoT first started being a thing was just a web server, which you could then, you port forward through your network, and people could dial in and turn his lamp on and off. And that was amazing when I first saw that. I really wanted. That was like reignited my love of IoT, because I started in 1999 doing IoT. We were making Royal Mail stamp vending machines that we were putting modems in, and we could dial into them across the country and pull out audit logs and stack traces and stuff like that, which to me was amazing in 1999. So that sort of stuff was great. Then later on I saw, one of those, the Clar things that, where you go and grab a prize by pressing left and right. Somebody had made an IoT version of one of those. So you just said how far forward and how far right you wanted to do, and you went into a queue and it would move the claw and grab something and drop it. You didn't win the prize, but actually just trying this online was cool. And that was the last one other than this that I've seen that does that. I've seen the Raspberry Pi, they've got a Twitch stream, and they're on there often, and they gave one, and I can't remember what the tech stack was, where you could move a little a little remote control car, an IoT car around, doing the same sort of thing. I can't remember what it was now, but you don't see much of this, and it would be fantastic. But for kids into IoT, just microbit, I love that. Make code, Microsoft Make code, block-based programming, or you can do it in Python or JavaScript as well. Tinkercad is fantastic as well to wire up circuits and then pull on an Arduino on there, write Arduino code in blocks and simulate it all without needing to buy the kit as well. Those two things is where I send kids that want to do IoT. That's awesome. And adults, I'm still a big kid.
No, you know what, mate? It was absolutely amazing. I really enjoyed that.
It was very good, John. Thank you.
Yeah, it was. I could just see your passion. This is your thing, isn't it?
Yeah, massive.
Yeah, and the same with John. He was absolutely all over this. He was loving it, and the passion was just flowing out.
Yeah.
But,
That's why John and I get on once so well. I think shared passion for that sort of thing, similar mannerisms as well. So
Yeah.
Oh, great sessions. Yeah. Thank you very much for coming on. I don't think there's any. I think there was a question from Simon, but I think John, your sidekick, managed to answer that one for you.
Yes, Padawan.
Where is Simon? Actually, yeah, I think he did.
No money you be bringing me.
Yeah, exactly. Lots of IoT tools you'll be using.
So, do you know this robot arm that you printed?
Yes.
Can you purchase it just off the shelf? Or
There are ones you can buy, but they're even more complicated. Cliff and I bought one. We ran this as a workshop, this talk, for the global Microsoft garages, and so we had a load of Microsoft staff who weren't necessarily au fait with building anything like this, and so we thought what we need is something that's off the shelf, and we bought a couple, and they're just complicated and horrible. So not very easily off the shelf, sadly. But what's great is that people like Cliff and myself to a certain degree. Cliff's got Prusa printers, by the way, Prusa 3D printers, and they're fast. And he's got more than one of them. And often he's at home when he's not flying planes. And so he's signed up to like a Prusa community printing site. And people go on there and ask for stuff to get printed if they've not got a 3D printer. So you go there, anybody it doesn't have to be a Prusa thing, but if you've got a Prusa printer, then that's what they guide you to do. So you can go onto that site, and I can't remember what it's called, but if you just start like Prusa community printing into Google, you'll probably find it. So if you can't get stuff 3D printed yourself, or you don't know somebody, then that's an option. And a lot of these people will do it for free, and they'll just ask you to pay postage. So that is a really good way. And certainly if you can do like Cliff's son's version of this, all you need to do is buy the servos and ask somebody to print the bits, and you don't need to buy anything else. You just wire in the servos, screw them in, and you're off and running. You'll need to buy the kit of parts. The kit of parts, by the way, all of this is in that GitHub repo. Everything you need to buy with some links there as well. Octoprint. Yes, if you got your own printer, then definitely Octoprint for the win. For that, Ender 3 for the win as well. Actually, there's a mega cheap price on it at the minute. It reduced it again, the Ender 3. I can't remember who it was that was reducing it, but Banggood is which is a horrible name for a company, is where John and I got ours from. But there's always places selling them, and they're dead cheap now because you have to build it yourself. But they just bang them out. Well worth buying one though, just for the fun, and then attaching a laser bloody attachment like John's done to it, so you can fry yourself alive.
I got one of them.
That was the one I saw. Yeah, there we are. I love that. Yeah, in fact, that might be the deal that I saw on Hot UK Deals, and it was £110 delivered from box. That is a bargain. And once you've got it set up, and setting it up is the hardest part, and John's quite right, that auto leveler that he's put in capital letters, that definitely helps with that. Getting a magnetic bed, that helps as well, and things like that. So, but there's so much community support out there for this because it's a community open source project. So yeah, that's great.
That's great. Thank you very much. I think we'll call it a night unless there's any more questions. For those who've missed out, this session will be on our YouTube channel, the Bradford Cloud User Group. And for those who have joined, thank you very much. Thank you, Peter. Thank you, John. It's been great having you both on. Absolutely amazing people. Yeah, thank you very much.
Thank you, guys. Great sessions.
Thanks for having us.
Anytime, guys. Great to see you.
Keep in touch. See you later.
Thank you.
See everyone. Bye.
Bye.